I think I am audible now. So I think now I'm perfectly audible and visible. Just tell me. Now mic is working, right? Okay. एक minute. नीचे गिरता. हाँ, done. So, first of all, welcome to PW NEET English. So, today what is the plan? Today we are going to finish, right? We are going to start ecology and we are going to finish it as well, right? So, what are we going to discuss? Only the NCERT part, nothing extra, only NCERT. But yeah, I will also consider NCERT exemplar part as well, right? Why NCERT exemplar? Like there are some terms in NCERT exemplar, sin ecology, this and that. So that few terms I will discuss. Otherwise, we will just stick to the NCERT. Okay. So many students, they requested for the ecology one shot. So after ecology one shot, what is going to be our plan? Dekho, it's very simple, right? We have already covered major topics, right? We are done with your plant physiology, hai na? They are the most scoring one. We are done with your human physiology, right? We have even covered the genetics part. Okay, now we have also covered the cell part also, right? Even you can check my previous videos also, in which biomolecule and everything is also discussed. And we have also covered biotechnology, right? And today we will finish ecology. And there will be one shot for diversity. I know some of you, they need the one shot for morphology and anatomy as well. So I am basically concising that part, right? I don't want you people to discuss or to read too much there, right? So whatsoever is important, we'll discuss that with you all as well. Okay. And if you think, madam, what about frog? What about cockroach? I'll give you one advice, right? There is no harm in discussing that. But the point is, you can expect, like from cockroach, rarely one question, right? From frog also one, rarely two, otherwise one question. So for that, you people can do one thing, just solve the PYQs beta, right? That I will definitely solve, right? I'll put a short video for that too, but do not give your time to those topics, right, which are not so scoring. So at this point of time, you have to go or you have to follow the SMART strategy. Ready? Okay, so now let's start the session. But before that, quickly hit the like button and share the stream with your friends and tell them that ma'am has started the session. Everybody quickly join. Okay, done. So one student is offering me, teacher, chocolate khalo. Thank you so much, beta. Thank you so much. Whenever we will meet in person, then do give it to me. Okay, right? And at least give me 2 to 3 chocolates, not just one. Okay, so let's start. Ready? Yes, everybody. Ready? Yup. Quickly tell me, ready? Yup. So some fire emojis in the chat that yes, madam, we are ready. Yes, madam, we are ready. Beta, my Telegram group is Love Biology by Ambika. Okay? We'll share that too. So let's start the chapter. Let's start with the basic thing, that is the organism and population. So first of all, see, term ecology. The very first thing is term ecology. So term ecology, who gave that? Anybody here in the class? And guys, as I said, quickly share the stream, right? Quickly share the stream with your friend as well. So term ecology, who coined this term ecology? So term ecology was coined by, who coined that? It was coined by Ernst Haeckel. Do we need to remember? Yup. Right. Father of Indian ecology. Next part. It is given in the introduction portion. So father of Indian ecology. Who's that? That is Professor Ramdeo Mishra. It's not Dev, it's DEO. Professor Ramdeo Mishra. And this is a NEET 2025 PYQ. It is from the introduction portion. Is that clear? Now, if you ask me, father of ecology, in some books it is Ritter, R-E-I-T-E-R. In some books, Alexander Humboldt. So that's why I'm not discussing that. So simply, term ecology was coined by Ernst Haeckel. Right, beta? So who's the father of Indian ecology? Professor Ramdeo Mishra. This is what we need to know. So beta, when we talk about this hierarchy, how do we start? In general, right? This is what you all know, that we have atoms, same atoms, right? There will be molecules, bacha. There will be elements, right? Molecules will be there, elements will be there, that are going to form the compounds. And when it comes to compounds, you know it very well, inorganic compounds are there as well as organic. Yes or no? Inorganic compounds are there, organic compounds are there. Organic will have the simple, I would say the simple one, the complex one, or I would say the monomers, right? The polymers, this and that. So all of them are making what? They are making protoplasm. What is protoplasm, beta? Please pay attention, everybody. What is protoplasm? Protoplasm is the living content of a cell. What is this protoplasm? It is the living content of a cell. What's that? It is the living content of a cell, right? This is what protoplasm is, or we can also call it as, it is also the physical basis of life. But ma'am, why are you teaching us this? I'll tell you. Just allow me 1 minute. So I am just starting this hierarchy. So what are we saying? Atom. Atom is giving molecule, elements, compounds are there. Then these compounds, be it organic, inorganic, they are going to form the protoplasm. What will they form, beta? They are going to form the protoplasm, which is the first living substance. Right, which is what? Which is the first living substance, which is basically the physical basis of life, right? And you know that this is what we have in a cell. It is the living component of a cell. So cell together will form what? Yes, everybody here in the chat, cell together will form tissue. Tissues together will form organ. Organ together will form organ system. And when you talk about the organ system, that organ system is going to give you what? Organism. Yes or no? Yes or no? So organ system together will form what? Organ system together will form organism. This is what we need to keep in our mind, right? That organ system together, it will make what? It is going to make the organism. Now, in the case of ecological hierarchy, right? In the case of ecological hierarchy, you people start from the organism. So that is what I am trying to tell you here. Right, that we start from what? We start from the organism. So when you talk about, right, so now that's why I started from the atom itself, beta. So this is basically the ecological hierarchy. What's that? It is the ecological hierarchy. That's what you need to know. This is the ecological hierarchy that you start from the organism, right? So atom, molecules, element, compounds, they will form the living entity, a living substance of a cell, that is the protoplasm. That protoplasm is the living component of a cell. Cell together forms tissue. Tissues will form organ. Organ will form organ system. And organ system is going to form what? It is going to form the organism. Yes or no? Yes or no? So when you people talk about the organism, so organisms are what? They are the basic or the smallest unit of ecology. What are they? Organisms, they are basic or the smallest unit of ecology. Don't worry, I'll discuss a definition of ecology as well. Right. So organism together will form what? They will form population. So what we have to remember here in population, this is what you have to remember. So when you are talking about the population, here we consider the individuals of same species. That's the keyword here, beta. Here what you have to consider, the individuals of same species. Are you getting my point? Here you have to consider the individuals of same species. So population will form what? Right? Population will result in the different populations, right, beta? They'll form community. Then you will have ecosystem. Then you will have biome. And then you will have biosphere. So this hierarchy is important to remember. And one by one, we will decode the meaning of these terms. Is that clear? Is that clear? Yes? Okay? Done, bache? So that's what you need to know. And that's what you need to remember. Is that clear? So what do you have? So organism, population, community, ecosystem, biome and biosphere is there. Is that clear? Is that clear? Done, beta? So what is the community? So in the case of population, you will talk about the individuals of same species. You will talk about the individuals of same species. And here we are talking about the organism, which is the basic unit of ecology. And at this level, like when you study that, so this is very important line. So at this level, right, basically when you are studying the organism, so what you people need to study or what you have to study, so at this level, ecology is what? At this level, ecology is basically what? Which ecology you will study at the level of organism. So ecology is basically the physiological ecology, right? It is the physiological ecology. So these basics you need to know first. Is that clear? Then we will start the NCERT reading. Are you getting my point? So when you are talking about the organism, it is the basic or the smallest unit of ecology. And when obviously when you are talking about this basic unit, what can you study about an organism? Just say you, me, what are we? We are an organism. Yes or no, Muskan? What are we? We are an organism. So at our level, what you people can study? How our body is working. So obviously it is going to be the physiological ecology, right beta? It is going to be the physiological ecology. Now another important point here is that individuals of same species, when you talk about the population, individuals of same species, they make the population of that area. So you are not going to say, yeah, you are not going to study it like this ki in an area, right, the dogs are also living, humans are also living, cats are also living, they are making population. No, when I'm using the word population, what am I specifying? Right, individuals, they should be of same species. So if your basics are weak, first understand that. Now community. Community means it is the integration, or I would say the group of population which are living under same set of environmental conditions. Right, beta? So when it comes to the community, what you have to say? What you have to say? So it is the basically the group of different kind of populations living under the same set of environmental conditions. Is that clear? So it is what? It is group या फिर assemblage of different kind of populations living under same set of environmental conditions, living under same set of environmental conditions and interact with each other. Is that clear? And interact with each other. So when you discuss this particular part, okay, when you discuss this particular part, then you are calling it as community. What do you call it, bacha? You call it as community. Then beta, ecosystem, the community which is having distinct species composition and structure. So you can say community integrated with its physical environment, right? Right, so it is what? So what is ecosystem? So ecosystem is basically community integrated with its physical environment, community integrated with its physical environment, right, physical environment. So community integrated with its physical environment, and there is an exchange of energy and recycling of nutrients. Is that clear? Recycling of nutrients. So this is what we study in an ecosystem, right? So in communities, we have different population. In ecosystem, we will see the community integrated with its physical environment, and there is an exchange. Is that clear? So biome is basically ecosystem spread over large area, and biosphere is beta sum total of all the biomes. Okay, beta? So biome is something which is the ecosystem spread over a large area. It is having specific latitude, specific conditions are there, right? So it is what? Ecosystem spread over large area, and here bache specific conditions are there, specific latitude, specific rainfall. So it is what we have to see here. And when it comes to the biosphere, so it is sum total of all the biomes. So that's what we need to remember here. Am I clear? Sum total of all the biomes. So that is what we need to remember here. This is what you have to keep in your mind. So this is what ecology is. Is that clear? Chali, next part here. Let's start with the NCERT. But yeah, before going forward, right? See, in general, no doubt, I started with this ki who coined the term, who's the father, this, and with this hierarchy we started. Now one more thing I would like to discuss here, right? One more thing that I would like to discuss here is that exactly, okay ma'am, what is ecology? I believe you all understand what exactly is ecology, right? Ecology. Logy means study. Logy means study, and here what is happening? We study that how, you know, an organism is working, yeah, how is it interacting with other organism, right? So, and basically when it is the ecology, you are considering the living as well as non-living component. You are considering that how everything is interacting. Is that clear? How everything is interacting. This is what we discuss. This is what we consider here, and that's what you need to keep in your mind. So what you need to see here when it comes to the ecology, you know that here there is the study of interaction between organism and their environment. What is it? It is the study of organism and their interaction with each other and with their surrounding. So this is what we study here, with their surroundings. So this is what we study here, beta. This is what we have to keep in our mind. Is that clear? Is that clear? So this is what ecology is, that how, right? It is a branch of biology which deal with the study of interaction between organisms, right? Which deal with the study of interaction between organisms. Like study of organism is also there, that is physiological ecology. Study of interaction between organisms, and so this part has covered it, beta, वैसे, and with their surrounding. This is it, and with their surrounding. So this is what ecology is. This is what ecology is. Anybody having any doubt? Anybody having any doubt? Yes. See, do you know about EP Odum? Odum, do you know? In higher classes, we study the books written by Odum, right? So EP Odum is basically the father of modern ecology, right? Who's he? He's considered as the father of modern ecology. Who? Odum. O-D-U-M, right? Odum. O-D-U-M. So as per him, ecology is the study of structure and function of nature, right? So ecology is what? Study of structure and function of nature. Any doubt, beta? Study of structure and function of nature. So this is what we study here in the case of your EP Odum's ecology. Is that clear? Is that clear, beta? Sure? Sure? Done? So, branches of ecology are there. This is the only extra thing that we are going to discuss. And even when you will solve NCERT exemplar, you are going to find this. So, there are two branches. One is beta autoecology. Another is SYN. Anybody in the class who's aware of it? One is autoecology, another is SYN ecology. So, anybody in the class who's aware of it? Yes, madam, it is having this meaning. Autoecology, autoecology or SYN ecology. So see beta, aut alone, that's how you can remember. So it is the study of, right, single species. How a single species, the individuals of single species, how do they interact with their environment? So it is the study of relation of single species, study of relation of single species with its environment, right? Study of relation of single species with its environment. That is what your autoecology is, right? Study of relation of single species with its environment, number one. In the case of SYN, here obviously you will not consider. So here the study of relation of single species, different species you are going to consider, right? So how that different species they are interacting with their environment. So that is what we consider here. Is that clear? That is what we consider here. Is that clear, everybody? Is that clear? Yes. So this is what SYN ecology is, that here you will study the relation of group of different species, right? Relation of group of different species with their environment. So here you will not consider one species, you will consider the different species. Done? Sure? Chaliye. So let's start with the let's start with this NCERT portion here. So here you people can clearly see, right? Our living world is fascinatingly diverse and amazingly complex. Yes, madam, this is true. Now they are saying, so we can try to understand its complexity by investigating the processes at various levels. This is what we discussed, like macromolecules are there, cells, tissues, organ, individuals. This is what we have. So that's how they have started: macromolecules, cell, tissue, organ, individual organs, population, community, ecosystem, biomes. And largest biome is what? It is the biosphere. Now what this next line is telling us, that at any level of biological organization, right, at any level of biological organization, we can have two types of question. For example, when you hear, so it is general thing, when you hear the bulbul singing early morning, you can ask, how do they sing? Or you can ask, why are they singing? So this type of question, just say how type of question will tell us about the mechanism, and why type of question will tell us about the significance. So is it relevant for us? Not at all. Now here again the general things they are asking, they are saying here that why are night blooming flowers generally white? How does the bee know which flower has nectar? Why does the cactus have so many thorns, right? How does the chick's purse recognize her own mother? So these are the another set of questions. So they are saying ki ecology, see, right, in basically in your previous classes also. So what is it? Here we study the interaction among organisms, how organisms are interacting with each other, how do they interact with their with other organisms, plus how do they interact with their physical environment. So whenever it comes to the ecology, you will consider biotic as well as abiotic factors both, right? What we have to consider here, we will consider both, bache, biotic as well as abiotic components. You will consider both sort of components here, biotic as well as abiotic, biotic as well as abiotic, both type of components we are going to consider here, beta. So that's what you need to remember. So how organisms they are interacting with each other, right? How do they interact with different organisms, plus beta, how do they interact with their environment? This is what ecology is. So next part, another important part. So I will only highlight the important things. So there are 4 levels of biological organization or ecological hierarchy. How many levels are there? 4 levels are there. Just you have organism, you have population, you have communities, you have biomes, right beta? So this is what we have just covered. Now next part which is given in NCERT is population attributes. So very first thing that you really need to understand is, I'm repeating this part again, right? I'm repeating this part again, right beta? So when it comes to population, population means individuals of same species. They are not the individual of different species, they are the individuals of same species. So that is what they are saying, that in nature we rarely find single individual of any species, है ना? Majority of them live in groups in a well-defined geographical area, obviously, right? You are not going to find that in an area only one individual of a particular species is living. No, they'll be in group, right? Either male, female, either there can be a group, beta. Even if you talk about the tribal areas, in the tribal areas also, basically there is a tribe, there is a group of people. So this is what we are trying to say here, that single individual of any species, right, you will not found, you will find them in groups. You will see that they will share or compete for the similar resources, bache. They will potentially interbreed. That's the word here, potentially interbreed, thus constitute a population. So when we talk about the potentially interbreed, you remember even in the case of species, that's how we define beta species, right? Group of individuals which can breed with each other and which can result in the formation of fertile organisms as well. So species. So when it comes to the population, what is the bullet point here? What is the main point here? The main point here is as simple as that. Population means group of individuals of same species. So although the term interbreeding, whenever we use the term interbreeding, obviously it means you are talking about the sexual reproduction, right? But you know that we have organisms which divide by asexual reproduction as well, right beta? Asexual reproduction as well. So they are also making the population. Is that clear? That here NCERT is saying ki, yes, I have used the word interbreeding, but interbreed word in general we imply for what? We imply it for sexual reproduction, right beta? Right beta? It is resulting from even asexual reproduction, like even individuals They result even from asexual reproduction. They also make the population, like bacterial population is there. How do they divide? Simple binary fission is there. So this is what they are trying to say. Now, all the cormorants, right? It's a bird in a wetland, rats in an abandoned dwelling, teakwood trees in a forest, bacteria in a culture, lotus plant in a pond. They all are the example of population only. This is what they are trying to tell us, right? So individual organism is the one. This is something amazing that you have to understand, that you have to mark. Individual organism is the one that will cope up with the changed environment. Individual organism will be the one which will cope up, right, which will deal with the changed environment. But it is at the, this is the most important line, at the population level, it is a natural selection that operates, right, and that will result in evolving the desired trait. Now let me elaborate that what exactly it means. It means, dekho, when it comes to the evolution, you will say that evolution is at the level of population. It is not at the level of a single individual, it is at the level of a population. Now you must be thinking, ki, madam, why is it so? Why are we talking about this? Why do we say that it should be at the level of population? Answer is very simple. Imagine if I will start evolving alone, right? If I will start evolving alone as in ki you will see the changes in me only, right? In my surrounding, nobody is having the same changes. So what will happen, right? Scientists, they'll come, they'll pick me up, they'll take me to the lab, they'll cut it, they'll check ki what is happening with me, right? And they will say what? That she got mutated, right? Though mutation is very important, right? Though mutation is very important for evolution, but for them, I will be a subject. Right? What will I be? I will be a subject for them, right? I'll be a subject for them, and they'll study that why she is so changed, what happened to her. Are you getting my point? Because I am only evolving. But if there will be the changes in the population, obviously they'll study that. They'll get to know this. So then it is like a complete population is evolving actually. Are you getting my point? Complete population is evolving actually. So when it comes to the natural selection, it is one of the most important statements here. So when it comes to the natural selection, that's what you have to remember. That's what you have to remember, that this will be at the level of, yes beta, at the level of what? At the level of population. Is that clear? So role of single individual is to cope up with the changes, to deal with the environmental changes. But overall, when it comes to the evolution, you'll talk about the population. So here they are saying, right here, what are they saying? They are saying that population ecology, which is obviously at the organismic level, it is an important area. Why? Because it links ecology to population genetics and to the evolution. Next, population is having certain attributes. Is it important? Yes, beta. Now they are saying, in the population, you will have birth, you will have, in single individual, you have birth and death. But in population, what do you say? Birth rate or death rate? That's something very important. Let me elaborate that, right? Let me elaborate that. Now, these are the another, this is the another basic part which you all need to understand. So you better pay attention, okay? So in the case of single individual, what you people will consider? You will only consider, in the case of single individual, you people will only consider what? You people will only consider, right, the birth and the death. You are talking about a single individual. Individual is living, individual is dead. That is it, right? I am alive, I am dead. That's it. But now you are talking about a population, individuals living in an area, right? This is the group of individuals of same species. So here you will see birth rate as well as death rate. What will you see here? Here you will see birth rate as well as death rate. Is that clear? What you people will see here? Birth rate as well as death rate. Is that clear? Is that clear? Are you sure? Right? So in a population, these rates refer to per capita birth and per capita death. You read NCERT so many times, but you never tell, right, never understand what is the meaning of per capita birth. Just for an example, and let me tell you beta, capital B, small b. These are two terms that we use. Capital B, small b. These are two terms that we use for the birth, right? But they are having the difference. Do you know that? what do they have? They are having the differences here. Just capital B is there, small b is there. So you cannot say that. No doubt here in both the cases you are talking about the birth, but they have distance. Just capital B is your natality. Capital B is basically for what? Capital B is basically for what? Number of individuals added. Small b is beta per capita birth rate. Per capita birth rate. Right? Small b is basically what? Small b is basically what? It is the per capita birth. So for small b, it is what? It is basically the per capita birth that you have to see, and this capital B, it is basically, as per foreign author books we are considering it, it is basically the natality. It is basically what, beta? It is basically the natality, that is the birth rate, production of new individuals in a population by birth, right? Done, beta? So if I have to define it, right? So per capita, my bad, per capita birth. Anybody in the class who can tell me the meaning here of per capita birth? Anybody in the class who can just tell me the meaning of per capita birth here? Ki yes, madam, this is the meaning of per capita birth. One student has mentioned shining star. Very good, ma'am. Small b is per capita birth. What is the meaning of per capita birth? Beta, it is the average number of birth produced per individual. This is the average number of birth produced. Average number of birth produced. Right? What's that? It is the average number of birth produced per individual. Per individual. Per individual. In a population, you are considering population, you are considering single individual plus per unit time. So what is this small b? Small b is the per capita birth. What is small b? Per capita birth, average number of births. Average number of birth produced per individual in a population per unit time. Right? In a population per unit time. Is that clear? Is that clear? And let me tell you, if we have to ever see this, it is like this. This is the formula. This is not required for you. In general, I'm telling you this. In general, I'm telling you this. And capital B in population ecology is basically natality, absolute natality. Right? So it is the total number of birth. Total number of birth in a population. What's that? It is the total number of birth in a population, and obviously time we will also consider here. So during a specific time. Now clear? During a specific time. Is that clear? So same will go for the death part as well. So B is per capita birth. So when I am saying per capita birth, here I am talking about average. I am talking about average number of birth in a population per individual per unit time. Per individual per unit time. So is the difference clear, beta? So capital B will be absolute natality, total number of birth in a population during a specified time. Small b will be the specific natality, that is number of birth per individual per unit time here. Right? Per unit time here. Any doubts here? Any doubt here? Done, beta? Sure? Sure? And beta, there is one more thing that you use, that is crude birth rate. Number of birth per 1,000 individual per year. There is one more thing, that is crude birth rate. What's that? Crude birth rate. So number of individual per 1,000 per year. So here you are specifying per 1,000 per year. So number of birth per 1,000 individuals per year. Number of births per 1,000 individuals per year. Is that clear? So same you can see for the death rate also. If you are using capital D, a small d, now it should be clear to you, right? So that's why I say this thing that beta, when I discuss NCERT, right, I'm just trying to make sure that you understand it, right? Here I'm not just to translate it. I want you people to understand the concept behind, then only you can answer all the question. And why this lecture is important for you? Because this lecture will directly give you 9 to 10 question. It can give you more than that as well, and you will get direct question. You're not going to see, or you're not going to find anything beyond NCERT. Directly from NCERT, direct MCQ will be there, statement based questions will be there, but we have to make sure that we understand everything. Okay, right beta? So a population has certain attributes, right? So which organism doesn't? Just birth and death. This is the case when you talk about the single organism. And when it comes to the population, you people will see what? They have the birth rates and they have the death rates. They have the birth rate as well as the death rate. So this is what you people need to know. Birth rate and death rate. So in a population, these rates refer to per capita birth and death. In a population, these these rates refer to what? These rates refer to per capita birth and per capita death. Per capita birth means you are talking about the average number of birth produced per individual in a population, but per unit time, right? So the rates hence expressed as change in number, that can be increase or decrease with respect to the number of population. So here they have given us one example. But before discussing that example, let me tell you that R is equals to B minus D. That's something you have to remember, right? R is equals to B minus D. That's something you have to remember. Now, how many of you know about the R? Yes, beta. How many of you know about the R here? R, quick. Yes, beta. What is R? Beta, it is the intrinsic rate of natural increase. It is the intrinsic rate of natural increase. Here it is B minus D, matlab per capita birth minus per capita death. It is the intrinsic rate of natural increase, plus it is also referred to as biotic potential, beta, right? So this is what we have, and this is something you again need to remember, that R is equals to B minus D. So R is equals to B minus D. That's something we need to remember. So as I said, intrinsic rate of natural increase, or it is the per capita rate of population growth. You can also call it as per capita rate of population growth. That's what you need to remember. Please keep it in your mind. That's what you need to remember. So per capita birth, per capita death, when you subtract that, you will get the intrinsic rate of natural increase. It is obvious. You are looking here and there. There is a population. Number of births are there, number of deaths are there. When you will check that per unit individual, per unit time, when you people check that, right beta, when you people check that, obviously you will subtract, you are going to get the value. This value will tell you that what per capita rate, right, whether it is increasing or decreasing. So this is something which is very important, right? This is something which is very important. So it is also referred to as intrinsic rate of natural increase. It is also what beta? It is also referred to as intrinsic rate of natural increase. So now here, let's suppose if R is greater than 0, it means population increases. Please keep it in your mind. If R is greater than 0, it means population increases. If R is greater than 0, population increases. If it is equals to 0, matlab population is stable, not increasing, not decreasing. So if R is lesser than 0 beta, then it means population decreases. So this is what you need to know. And for our country, you know that population is increasing, right? For our country, population is increasing. So these are the details beta which you need to know if you really want to understand that. Is that clear? If you really want to understand that. So as per NCERT, R is the intrinsic rate of natural increase, a key parameter even in the exponential growth rate. So this is clear, right? So now you can see here they are talking about what? Here they are talking that if in a pond there were 20 lotus plants last year 20 were there, new plants they are 8. Last year 20, new plants they are 8. Right, total will be 28. Now you have to calculate this birth rate. So how are you calculating it? You are considering new birth. You are considering new birth, and beta, in their case also n is the population size. N is the population size, your population density. So new birth is 8, N was 20 then, right? At that time it was 20, so you have 0.4. That's what you need to know. So what is the common mistakes that students make? They, instead of writing here 20, they write 28. They consider the total. No, because you have to check what? You have to check the birth rate, beta. So if you have to check it, so you will take the new births and you will take that initial population size there, right? You will get 0.4 offspring per lotus per year. So if 4 individuals in a lab of 40 fruit flies they are talking, they died during a time interval which can vary. Here it is a week. So death rate, how will you check? 4 by 40.1. So this is the important part. If you will solve the PYQs, you will definitely get the question from this particular part. So another attribute in the case of, let's stick to the NCERT, otherwise I would have discussed many things. So population is sex ratio as well. So individual can either be male or female, but population is having sex ratio like 60% of the population is female, 40% are male. So you know, such studies, they also teach us many extra things. Jaise Haryana, Rajasthan, not now, like many years ago, right, when this was checked, so it was found that males, they were more, females, they were less. So somewhere it was directing to the female feticide as well. So there are many, you know, dark secrets also, which we can here relate with the ecology. We can discuss them in a better way. We can understand them in a better way. But now time constraint is there, so I cannot go there. So we will stick to the NCERT. So once beta your RE-NEET will be over, and obviously after that, the exam should not be there again. So matlab it should be final one. Last time I was saying the same thing, ki beta once your exam will be over na, we are going to start a new series, we'll do this, we'll do that. So after 21st of June, we'll give you a time 10 to 15 days to process whatever you want to, and then we will come up with a new series. Okay, we'll discuss that. And meanwhile, Yaqeen NEET English batch is also live. Immediately after the RE-NEET beta, classes will start there as well. Okay. So sex ratio is also there. Now, next part that they are saying is that population at any given time is composed of individuals of different ages. Population at any given time, it is having the individuals of different ages. Just here, so this is the age distribution beta. So age distribution is another important PYQ, another repeated question. So age distribution is percent individual of a given age or age group. Right? Just say we have 3 age groups here, beta. We have pre-reproductive age group, reproductive age group, post-reproductive. Pre-reproductive, which are not reproducing. Reproductive one, which are in that reproducible age. Post-reproductive, again, they are not reproducing. They are, after that, older age people will be here, right? Older age people, they are going to be, we will consider them here. So there are 3 types of age pyramids. So in different countries, different type of age pyramids are there, right, beta? So here you can see, just a human population, age pyramid will show age distribution of males and females, bache. So here you will have pre-reproductive. So you should know pre-reproductive age group is at base. At top, you have post-reproductive age group. In the middle, you have reproductive age group. You won't believe, but this is also PYQ. Now, when will it be expanding? That is triangular. It is triangular age pyramid. Means population is expanding. Expanding means positive growth is there. Means population is growing. Just when you will be having more individuals of pre-reproductive age group, right? Maximum individuals of pre-reproductive age group, reproductive age group are lesser, post-reproductive are right, at least. So this is the triangular age pyramid. So your population is growing. It is the stable one. Stable one means bell-shaped. Bell-shaped age pyramid will be there. Here you will say population growth. What will you call this population growth? You will say population growth is at 0. What do you say, beta? Population growth is at 0 here because it is stable. Pre-reproductive and reproductive age group, the individuals of these age group are almost same, right? They are almost their number is almost similar. And then lesser one is the post one, and declining, which is even the urn shaped. Done, beta. Here you will see the growth is negative. So positive, 0 or negative it is. So lesser will be here. Lesser will be pre-reproductive age group, right? Young people, they are less. If young people, they are going to be less, obviously in that country the population growth will be declining. Just say for an example, there are other factors also. Just say I'll give you one data. Just say when that COVID wave was there, many individuals from Italy, they were dying because in Italy also there is more population of old age people, so they were dying too much. So these are also the things that we see when it comes to the population, right? Okay, done bache? Any doubts? Sure? Done? Now, initially, beta India, because you know that we have the largest population. You won't believe, beta, you won't believe that as per the previous text also, that India was also in the triangular age pyramid because we were growing. But now it is believed that we are somewhere in that stable wala thing, right? It is believed, right? Because you know that many people, they are not even reproducing, they are adopting no child policy also. So there are things. So now it is somewhere near to the stable. Okay, done. Chali, next part. So here again, another important thing, very simple. So size of population, that is N, tells us a lot about its status. Obviously, beta, obviously. So population, right? Obviously, it is the outcome of competition. We are not living alone. We are living with the individuals of same species, plus we are living with the individuals of different species. So competition will be there. As per that competition, obviously, will we see the population size in a particular area, that will tell us, right, that whether it is growing, whether it is declining. So here they are saying the effect of competition, the impact of predator, effect of pesticide, all will be there. All will be there. All are responsible for population change. So now here, the point is that the size in nature could be as low as less than 10. That is Siberian cranes at Bharatpur wetlands in any year, right? So birds, they show the migration now. So in Siberian cranes, they come to Bharatpur wetlands, beta. So their number can be less than 10 and their number can be in millions, like Chlamydomonas, which is a unicellular algae in a pond. It is in millions. So population size, that is N, is not measured by number only. So population size, population density, right, it is the capital N that will denote that. Okay, so you cannot just measure it with the numbers, though number is the most appropriate measure, right? Though the number, measuring the population density by number is the most appropriate measure, but you cannot always do that, right? Just say for an example, here they are giving us the example. If there are 200 carrot grass, that is Parthenium hystrophorus, which is basically an invasive species, right? Parthenium. In the chapter Sexual Reproduction in Flowering Plants 2, beta, we discussed that, right? Parthenium, which is also the carrot grass. It is also referred to as the Congress grass. So carrot grass or Congress grass it is. So it is invasive. You all have seen that, right? Greenish, having very small white colored, like that looks like flower. It looks like cauliflower, chotu sa, very little flower, right? White colored flower. So it is actually an invasive species. And let me tell you, this is the one whose pollen cause the allergy as well, can result in asthma. Okay, so now you are comparing here these 200 carrot grass or Parthenium grass with a single huge banyan tree, right? With a single huge banyan tree with the large canopy. With a single huge banyan tree with the large canopy, stating that the population density of banyan is low relative to that of the carrot grass, right? Right. So what are they saying? Now here what are we considering? They are saying you consider 200 Parthenium grass. Now you compare it with one huge banyan tree, right? Banyan tree, basically the ficus species, right? So obviously what are they saying? We cannot just ignore, we cannot just focus on the number, and we cannot just ignore the role of banyan tree in that community, right? That is a large tree, beta. It's biomass, the oxygen it is giving, it's a place or a shelter for many birds. So many things are there. So we cannot ignore that role. So in such cases, what we have to do, the percent cover. What is the meaning of percent cover? That is biomass is the more meaningful measure. So always it is not just the number that we will go. No doubt number is the most appropriate measure, But beta, other than that, right, we have the biomass and we go for the relative densities as well. So in this case, biomass will be prioritized. So biomass means that organic matter, right? So total number is again not an easily adoptable measure if the population is huge and the counting is impossible. Now they are giving us third example, beta. They are giving us third example कि sometimes we don't know the absolute population densities, but relative densities serve the purpose equally well. Just let's suppose there is a lake. There is a lake. You want to check whether that lake is having fish or not. Right? You want to check it. So it's not like you are going to swim, you are going to hold each and every fish and you are going to put a number. Okay, fish number 1, fish number 2, fish number 3. No, what we do? We are going to put a trap there in that lake. Right? So number of fishes, if it is rich with fishes, they will be more. If there is another lake, if there will be having less number of fish, so obviously you will say कि lake number 1 was having more fish. So this is what they are saying, कि number of fish caught per trap is a good enough measure of its total population density in a lake. So we are mostly obliged to estimate population sizes indirectly without actual counting them. So जैसे tiger census, solve PYQ, you people will find this also. Tiger census in our national parks and tiger reserves is often based on pug marks and fecal pallets. Is often based on pug marks and fecal pallets. Is that clear? So tiger census in our national parks and tiger reserve is often based on pug marks and fecal pallet. Now next part, next question. So the size of population for any species is not a static parameter. It is not something, right? Static, you understand? What is the meaning of static, beta? Jesse, you also talk about the static electricity. So what is the meaning of static? Anybody here? What is the meaning of static? Quick. Yes. So beta, populations, when you are saying static parameters, so static parameter means you are measuring it at a particular point in the time, right? So it describes the population status rather than the changes. So its size of population is not a static matter, not a static parameter, right? Not a static parameter, right? So static word, I hope you are clear, means something which is static, means something which is not fixed, right? Right, static means something which is unchanging or fixed at a particular time, right? Which is not changing, right? Unchanging, that is the meaning of static, right? Okay, that is fixed, unchanging. So that is basically the static parameter. So it keeps changing with time. So population, they are saying, is not a static parameter, means it is not something which is fixed. It is not static. It is not, right, not static. So static means what? Static means what? Something which is fixed, something which is unchanging. But we are saying ki size of population, right? Yeah, population density, that is N. So N, if in the paper, if I have to give you a statement based question, so I can ask you, N is what? N is not a static parameter. So that's how you have to understand it, or you have to remember it, that N is not a static parameter. Is that clear? N is not a static parameter. It keeps changing with the time. It depends on various factors, beta. It depends on the food availability, predation pressure, adverse weather. Just for an example, if in a particular city, if you observe that the population is increasing, so there must be more job opportunities, better education. So it is like that. So these are the things which you have to, remember. Is that clear? Is that clear? So it is these changes in population densities that will tell us what is happening. Just say in a particular area, if in a particular city too much crowd is there, matlab that city is providing more job opportunities, better life is there, that is why people moving to that area. So it is like that. Okay, so in an area, if I have to see, right, the status of that population, okay beta, so it depends on many things, the availability of the food, the level of the predation pressure, the competition, all the factors will be considered here. Is that clear? Right, so that will tell us whether population is flourishing or is it declining. So this is what you have to remember. So whatever will be the ultimate reason, the density of population in a given habitat during a given period, right, the density of a population in a given habitat during a given period, it fluctuates due to the changes in 4 basic processes. So here natality, immigration, mortality, emigration, that's what we have to see. So these are the 4 factors, and it is also one of the most repeated topic, right? This is the most repeated topic that you need to understand. It is what? It is the most repeated topic, beta, which you really need to understand. So when it comes to the natality, right, new birth, so obviously it will help in the growth of population. It will help in the growth of population. So it is a number of birth during a given period in a population. Just I told you capital B, natality. I told you it is a total number of birth in a population in a specific time. So here they have said number of birth during a given period in a population. Just small b is for per capita birth. Okay, small b is for per capita birth. So here what do you say, beta? Here what do you say? That it is the number of births during a given period in the population that are added to the initial density. So initial density, just say let's suppose initially 1000 individuals were there, right? After new birth 70, so it will be 1070. So obviously it is like a plus factor. It is helping in the growth of population. It is increasing the population size. Then comes the mortality. What is it? It is the number of death in a population during a given period. So it is what? It is the number of deaths. Number of deaths, obviously it will decrease. Then immigration, in, that's what you can remember. Like new individuals, they are coming to a place. So let's suppose 70 new birth, 50 new individual came to that. So you will add here, right? You will add here, this is going to be this. Hai na? So emigration, what that will do? E for exit, the individuals which are leaving. So it is the number of individuals that are going to leave that place, okay, when you are considering this. So this is the, I told you this is the most important topic. So population density, population size, and so natality plus immigration plus, both these factors, they are contributing, they are helping in increase in the population size. These 2 factors, they are decreasing it. So if you have to see the formula, so you can go for this. Nt plus 1 is equals to, first you have to consider it at T plus birth plus emigration minus death plus emigration. Obviously these 2 factors are contributing, these 2 factors are decreasing, so we will subtract that number and accordingly we'll get the population size at time T plus 1. So this is important, this is easy. And when beta there is, right, there are some special conditions also. Just say, let's suppose if there is a new habitat, just say in general, this natality and mortality, it is believed to be the most important factor. Natality and mortality, it is believed to be the most important factor which contributes in the population size. But beta, when there is a new habitat, there is a new place there, the immigration is going to be the most important factor, right? So in special cases, emigration can be the main factors. Just say for an example, if there is a new building, new colony, new place, so here what matters? That how many new individuals they start living there. Okay, so these are the things which you have to consider, okay? These are the things which you have to consider. So N is the population density at time T, then its density at time T plus 1 will be this. So formula is important. So no doubt I told you, number of birth. So this is what you can conclude. Right? Just say if the number of birth plus the, see, if B plus I is more than D plus E, then N increases. Matlab N at T plus 1 increases. And if D plus E is greater than B plus I, then obviously it will decreases. So these are the things which we need to keep in our mind. Is that clear? These are the things which we are supposed to keep in our mind. Okay. So next part is saying what? That under normal conditions, when the conditions are normal, birth and death are the most important factors, right? But other 2 factors, they will be only under special conditions. Just say if there is a new habitat, right? It is just being colonized, immigration will contribute to it more. Done? Chale, next part, it is regarding the population growth models, where we will discuss. One is your dreamy word, another is the reality check. Just say some students, right, they'll chit chat, they'll use mobile phone, right? They will not give mock test. They will just imagine, right? Like some students now, they consider manifestation in a different way, right? Some students, they think manifestation means that you just need to, है ना, you just need to think good and it is going to eventually happen. Beta, it also depends on your efforts. You have to, let's suppose if you are manifesting something, let's suppose if I'm manifesting that I'll get selected in MBBS, I'll get seat in AIMS medical college, है ना, in any of the AIMS colleges. So obviously, right, when I'm not working hard for that, when I don't work hard, when I know I'm not working hard for it, so whenever I'll try to manifest it, it is going to tell me, like somewhere, you know, that voice will be there. You're not working hard, how can you even think of that? You're not even working hard, how can you even think of that? That thing will definitely come, beta. So when you manifest something, so when you put efforts, you know you are putting efforts, and even you are having that positive mind, you are manifesting it. Now because you know you are putting efforts, so eventually you will get the result as well. So this is how the things are. Same, these growth models, in this way I am going to explain you. Just say one is exponential growth, right, which is also the exponential growth, which is also the J-shaped growth model. One is basically your sigmoid, that is Verhulst Pearl logistic growth curve model. Verhulst Pearl logistic growth curve model. And another is exponential, which is basically J-shaped growth curve model, which is basically J-shaped growth curve model. Are you getting my point? Are you getting my point? Hanji. So this is what we have to discuss. I'll give you an example and I'll tell you what you have to do there. Dekho. Imagine you are like, oh my God, you're not even studying, you're thinking, oh my God, I'll give the NEET, RE-NEET examination, I'll get 710 marks out of 720, I'll get admission in AIMS Delhi or whatsoever is your favorite medical college. There I will go, I will start my, YouTube channel, right? I'll get so many followers on Instagram also. I'll start making money from the YouTube, from the Instagram, and I'm already doing MBBS. I'm just growing. One day, let's suppose you are like, some famous YouTube, some famous actress, anybody can be, right? She will fall in love with me, and oh my God, then we will go do this, we will do that. Dreamy word. You're not doing it, you're thinking. And I'll go to AIMS, I'll start YouTube channel, that will also grow, Instagram also grow. One day a beautiful girl, she will also fall in love with me, and then our life will be like this. This is a reality. So this is the dreamy word. This is what your exponential growth is, right? That resources, food and space is unlimited, population is growing, and living its lifespan, right? Full lifespan. Now the reality check. You are thinking, but then you have to give the exam. Exam day, you'll have the anxiety. Difficulty level will be there, right? Plus, after that cutoff thing will be there. Merit will also be there. By any chance, if you will get the admission and then you will like, I'll start the YouTube channel. When it comes to that, there also the competition will be there. So this is going to be the reality check. So when it comes to the exponential growth curve model, it is your dreamy word, right? Which you just dream. Okay. Verhulst Pearl logistic growth curve model is the reality check here, right? That initially population growth will be slow, then exponentially, but now competition is also there, limited food and space, right? Struggle will also be there, and then there will be the stationary phase. So in the case of exponential growth curve, right? Exponential growth curve, resources, that is food and space, availability is obviously essential for the unimpeded growth of population. They are saying what we need for the population growth, right? The resources. So let me write it here as well. It is the J-shaped population growth curve. It is the J-shaped population growth curve. What's that? It is the J-shaped population growth curve. So we are saying that resources availability is essential for unimpeded growth of population. So ideally, when resources in the habitat are unlimited, Each species has the ability to realize full its innate potential. When resources are unlimited, competition is not there for the food and space. So obviously organism, they'll live to their full potential, right beta? They'll grow in number. So Darwin also observed that while developing his theory of natural selection. This is what Darwin observed. When resources are unlimited, when food and space is unlimited, population grow, yeah, individual grow, or they realize full biotic potential, right? Full biotic potential. So this is an exponential, or this is the geometric fashion. The growth is in the exponentially or in the geometric fashion. So here they have given us, so D, differentiation, you remember dn over dt is equals to Rn. So dn means change in n in time t. What is this dn over dt? Right, that there is a change, right? This is telling me about the change. So change in population size, change in population size during a time period t, during a time period t. This is what we have. So R is B minus N. So dn over dt is equals to B minus dn, isn't it? Because we know what R is. So R, what I told you what R is, beta. So R is the intrinsic rate of natural increase. So question can come from this side also, right? So this is also a PYQ. Okay, beta. Okay, beta. So it is a very important parameter which is chosen for assessing, right, the impact of biotic and abiotic components on the population size. So obviously R will tell us whether the population is growing or decreasing. So I told you, if R is more than 0, your population is doing what? Population is showing an increase. Remember that. If it is 0, this is going to be stable. If it is lesser than 0, then you know that population is decreasing. So here they are telling us that Norway rat, the R is 0.015, and for the flower beetle it is 0.12. So in 1981, the R value for human population is this, 0.0205. Do remember that. Now they are saying, what about the current R value? So currently I told you that it is kind of stable. Yes, beta. Yes, kind of it is stable, right? So value, if you talk about its value, so these are the parameters that you have to remember. So as per, so its value, beta, though its value is basically, I would say somewhere around 0.0089, okay? Okay. India R is basically, in India, beta, it is around still positive. Done? For India, it is still positive. For India, that is why we are saying, it is increasing. Right? So it is not like that our population, why do I just say it? Why do I am saying that it is stable? Like, it is stable because it is not growing at that rate with as the previous rate. It is not growing as per the previous rate. But yeah, still beta R value is a kind of positive here. Okay? Okay. Done? Any doubts? Any doubts here? Sure? Chaliye. So you can see here, so the exponential or geometric growth pattern of population is there. So it is the J-shaped curve, right? So we plot n in relation to time. So it is nt is equals to n naught ERT. Is that clear? Nt is equals to n naught ERT. Nt is equals to n naught ERT. Got it? Nt is what? Nt is equals to n naught ERT. So Nt is what? It is the population density after time t. N naught is population density at time 0. R is the intrinsic rate of natural increase. E, that is again a PYQ. It is the base of natural logarithm. 2.71828 is the value there. Okay, beta? Okay. So when the conditions are unlimited, like food and space is, there is no bar on food and space. Even the slowest breeder, like elephant. You know, elephant is the slowest breeder, right? Elephant is the slowest breeder. That can also attain its maximum potential. So do check why elephant is the slowest breeder, right? It depends on its gestation period. Even the elephants, they attain their sexual maturity later, right? So these are the things, right? Their gestation period also, you know. So do read about it. Do read about it. Right, that's very interesting. So this is what they have given. So x-axis is telling me about the time, y-axis is telling me about the density here, and here this a is basically my exponential growth, geometric growth, right? So this is the exponential growth curve. So dn over dt is equals to rn. Now beta, here in this particular diagram they are talking about the k. What is k, bache? K is basically the carrying capacity. Now this is what you need to understand, then we will read it from the NCERT. So K is what? K is the carrying capacity. Carrying capacity. Just every place is having a capability. Just let's suppose if there is a classroom, that classroom is having the sitting arrangement for 100 students only. There is a hotel which can accommodate only 50 individuals. So this is the carrying capacity, right beta? Now, when the population is growing, initially, let's suppose its carrying capacity is at this level. Initially, when population growth is at this level, fine, resources are unlimited, resources are available to every individual. Now, let's suppose if population is growing. Now, carrying capacity means how much a place can accommodate. As per the resources it is having, as per the space it is having, as per the food it is having. So now my point is, if population will rise, right, and population increases too much, so beta, when it will try to reach out this k, na, when it will try to reach out this k, no, when it will be closer to this k, the competition will be too much. The resources will not be available for every individual. The struggle will be more. The struggle will be more. So even your Darwin, right? Even in evolution chapter also you understand that. Just Darwin was quite impressed with the work of Malthus. Malthus population growth curve model. So Malthus was like, ki, when it comes to the resources they grow arithmetically. Just 1, 2, 3, 4, 5 like this. When it comes to the population, it grows geometrically. Just from 1 to 2, 2 to 4, 4 to 8, 8 to 16 like that. Now, population is growing at a faster rate. Resources are obviously not that much growing. So what's going to happen in that scenario? What is going to happen in that scenario? Obviously, the competition is more, the struggle is more. So as per Malthus, any factor which is keeping a check on population growth, that will be a positive factor. That will be a positive check. That can be anything. That can be any catastrophic effect as well. Just as per Malthus, population is growing. Nature has to make sure nature will try to keep a check on that, right? So any catastrophic effect can be there. There can be earthquake, there can be cyclone, there can be flood, there can be any disease, any pandemic can be there. So Malthus was like, they are the positive check. They are the positive checks. Why? Because they are maintaining that population, which is important, which is required as well. Which is important, which is required as well. So basically, what is the point? That n is increasing. So when n and k, when they are equal, when n and k, they are equal, it is asymptote. It is asymptote. What's that, beta? Asymptote. No further increase will be there. That is again a PYQ. So k is equals to n, it is the asymptote. It is the asymptote. So this is what you have to remember. So dn over dt, right? So here in the case of this S-shaped growth curve model, in the case of this S-shaped growth curve model, which is sigmoid growth curve model, which is Verhulst per logistic growth curve model, in this particular case, right beta, you consider carrying capacity, plus you will also consider, which is again NEET 2026 question, environment resistance also. You consider environment resistance also. That is, so I remember it like this. Kaan ke niche kaan. In Hindi it is, I'll explain. Kaan ke niche kaan. KNK, KNK, KNK. That's how you can repeat. Kaan, KN. Ke niche kaan means below that also K is there. So KNK, 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 that's how you can remember. K minus N over K. Right? KNK, K minus N over K. That's how you can keep it in your mind. Okay, so this part here is showing the environmental resistance, because obviously when population will grow, bache, population will grow, right? The carrying capacity is there. Below that, beyond that carrying capacity, it will not grow. So initially you people will see the lag phase, then you will see the log phase, also the exponential phase, then comes the stationary phase. So when k is equals to n, it will be asymptote. So here you people can see that. Okay, please have a look. Any species growing exponentially, any species growing exponentially under unlimited resource conditions, right? Any species growing exponentially under unlimited, right? Just a minute, beta. So any species, one second, please. Guys, just 1 minute, please. Okay, so any species which is growing exponentially under unlimited resource condition can reach enormous population density. So Darwin showed, beta, Darwin showed how even a slow growing animal like elephant can reach to its enormous number in the absence of checks, right? That how, right? Darwin showed how even a slow growing animal like elephant could reach enormous number in the absence of checks. So falling is a anecdote popularly narrated to demonstrate dramatically how fast a huge population could build up when grow exponentially. So in simple words, they are trying to say that even the, already told you, slowest breeder like elephant can also grow exponentially. It can also attain its maximum biotic potential if competition, if resources are unlimited, if checks are not there, if resources are unlimited, right beta? Right beta? So this is important. So the another example that they are giving is, right, the king of ministers said for chess game, the king confident that king will win, right? So he accepted a bet proposed by minister. So minister was like, if he won, he wanted only some wheat grains, the quantity of which is to be calculated by placing on the chessboard. Now you know the chessboard, 1 grain in square 1, then 2 in square 2, then double of that 4, then 8, then like this. So you have to double it every time, right? So king accepted the seeming silly bet and started the game, but unluckily for him, right, the minister won. The king felt that fulfilling the bet was so easy, so he started with a single grain. But later on, what he observed, by the time he covered the chessboard, half of the chessboard, the king realized that all the wheat produced in his entire kingdom pooled together. So it is like that, like doubling was there, right? So not required for us. Baki here paramecium, so they are giving us example, just a tiny paramecium, if it will just start with one individual through binary fission, doubling in numbers every day, imagine what a mind-boggling population size it would reach in 64 days if it will not be destroyed, beta. So this is what they are saying. So next is logistic growth curve model. Next is logistic growth curve model. So it is beta S-shaped growth curve model. It is also known as Verhulst-Pearl logistic growth curve model. Verhulst-Pearl logistic growth curve model, right beta, S-shaped. So no population of any species in nature, beta. So that is why I say that it is the so here it is, there will be sigmoid growth. So that is why beta I say that it is the reality check. So no species in nature has at its disposal unlimited resources to permit the exponential growth. The resources will be limited, the competition will be there. So obviously competition will occur beta because resources are limited. So eventually the one which is fittest, right, which can overcome all the hurdles will survive and will reproduce. So government of many countries, they have also realized this and introduced various restraints and a view to limit the human population growth. Now in nature, given habitat has enough resources. This is a wonderful line beta. So given in a given habitat, they will be having the resources to support a maximum possible number, beyond which there will be no further growth, that is K. So beyond K, so what can you conclude from this particular part? You can simply conclude that beyond K, there is no population growth. And once again, K is equals to N means it's asymptote. That's it. K is equals to N means asymptote. So here a population growing in a habitat with limited resources will show initially what? A lag phase, then a phase either of acceleration or deceleration, and finally an asymptote. When the population density reach the carrying capacity, a plot they have given us. So it is also the Verhulst-Pearl logistic growth curve model. So dn over dt is equals to Rn, but here not just Rn, you will also consider K minus N over K. So what is this K minus N over K? Already told you, this is the environmental resistance, right beta, right? So since resources are finite and become limiting sooner or later, logistic model is the realistic one beta. So gather from government census data that the population for growth for India in last 100 years. So that is it. Let's move to the next part. So next part is telling me about the life history variation, then the population interaction. So in next 30 minutes we will finish this, right? 30 or 35 minutes we will finish this, and then beta we will move to the MCQ practice, and then we will move to the next chapter. Ready? Chaliye. So next, what are they saying? So they are saying that population evolved to maximize their reproductive fitness, which is the Darwinian fitness. So one MCQ or one question that I should know is that reproductive fitness is basically the Darwinian fitness. So I would say obviously firstly it is at the individual level, then it is the population which is going to show the evolution. So what you have to see that the population will evolve to maximize its reproductive fitness. Population will evolve to maximize its reproductive fitness. Is that clear? Population will evolve to maximize the reproductive fitness. Is that clear? Is that clear? Sure? It's reproductive fitness. So that's something which is important, right? That's something which is important. This is something which you need to know as well. So they are saying that population is evolving to maximize their reproductive fitness. That is the Darwinian fitness. That is high R value. So that's how you can make the short notes as well, right? That's how you can make the short notes as well in the habitat where they live. So under the particular set of selection pressure, organisms, they will evolve towards the most efficient reproductive strategy. Here you have to understand one thing. We are talking about the most efficient reproductive strategy. Here you cannot say that there will be one strategy that will work. Like every student is different. They have different approach. That is normal. Moreover, you know that their caliber, like some can be good in physics, other can be good in chemistry, like that. We know it very well, right? We all are well aware of it. So what I want to tell you, you cannot say that there is only one strategy which is best, right? There are many strategies, beta. Maybe for me, strategy A is working, but maybe for you, strategy B is working. Maybe for some other person, strategy C is working. So it is like that. Are you getting my point? It is like that. So A, B, C, this is what we have, right? Different individuals can have different strategies and that can work different for them. Maybe the thing which is working for you, it might not work for me. So that's what you have to keep in your mind. So each and every individual, they try to maximize their reproductive fitness, that is Darwinian fitness, and that will be as per their habitat, as per their level of organization. Just for an example, if I talk about a cockroach is going to give birth to it will lay so many eggs. Why? Because parental care is less, right? It will, why so many individuals? Why so many individuals? So that even few should survive out of that, right? And they will be of small size, they will be large in number, right beta? They will be large in number. Yes or no? Yes or no? Yes beta. Yes or no? So this is something that you have to keep in your mind. Now in our case, the individual, lesser number of individuals are there, the size is larger, parental care is more, so we know they will survive. So that is how these strategies, they work beta. So we have our strategists or case strategists in ecology, so we will discuss about that too. Is that clear? Is that clear? So you can see here that some organism, they breed only once in their lifetime. Examples are important: Pacific salmon fish or bamboo. And now that chapter is deleted, there is one Strobilanthes kunthiana, right? We used to discuss this Strobilanthes kunthiana, right? Neela Kuranji. So this is a flower, Neela Kuranji, in the southern part of the country. So it beta flower every 12 years. So you can read about that. You can read about that. So it used to be there in one of the chapters. Now it is deleted from your syllabus, reproduction in organisms. So this flower is going to bloom after every 12 years. So when it comes to breed only once in their lifetime, as per the NCERT, we will go. So Pacific salmon fish and bamboo is there. Pacific salmon fish or bamboo is there. While others, they breed many times during their lifetime, like most birds and mammals. Like what? Like most birds and mammals. Like what? Like most birds and mammals. Is that clear? Is that clear? So what is going to happen here? So some produce a large number of small sized offspring. Pay attention. Number will be large, size will be less. Just oysters, pelagic fishes, right? While others produce a small number of large sized offspring, just birds and mammals. So why, which is describable for maximized fitness? So ecologists are like, the life history trait of an organism have evolved in relation to the constraints imposed by biotic and abiotic components of the habitat in which they live. As I told you, that which strategy is better for which individual, it depends on its level, where that individual is living, the kind of habitat and everything, all the factors will be considered here. So evolution of life history traits in different species is currently an important area of research being conducted by ecologists. Now here I would like to specify a few things, right? So it is not a recent PYQ, but yeah, it is a question it is a topic that you should know. Dekho, first is life history variations we were discussing. So I told you already, the organisms which are living under more threat, the parental care is less. They'll give birth to many organisms of small size. Another organisms where parental care is there, they are not living under that threat. So they can just give rise to larger sized offspring with lesser number. So this is how everything is related to each other, and that's what you need to keep in your mind as well. Are you getting my point? Now, what's the next point that you all need to understand here? Just say, I'll give you an example. Like I have one habit. I don't go for buying so much of stuff. Ki I need this, I need that. Right? Matlab, jaise, let's suppose, I say this is our trait, right? It's a girl trait. We need so many clothes. right? We need so many clothes. But in my case, and especially so many footwears, so in my case, one thing is simple, right? I will buy a single footwear, but that should be of good quality. I don't go for quantity, I go for quality. That should be good, right? That should be good, that should be of good quality, like that. So I have seen some girls in where, you know, earlier when we used to live in PGs or something, right? So they used to buy so many footwears, not of the good quality, but they like the number, ki I should have this and that. And I am somebody ki I'll spend money once, I want something which I can use for at least for 4 to 5 years, right? So it is like that. It is like that. So here it depends on habitat, it depends on such things. So R strategists are also there, K is also there. So R obviously related to the intrinsic rate of natural increase, K is carrying capacity, you know. So when it comes to R, right? So here R basically means unstable conditions. Here what sort of conditions are there? Unstable and unstable conditions are there, and they are unpredictable as well. Is that clear? So it is unstable and unpredictable. And here you will see population size fluctuates. Done. Population size in their case, it will do what? It fluctuates. So reproduction is early and rapid, and number of individuals are maximum. So reproduction is early and rapid. So number of individuals number of offsprings they are many. Are you getting my point? So number of offsprings, here what will you see? Number of offsprings are many. So parental care, either it will be beta little or none. Little or none. Even lifespan is also short here. Lifespan is also short here. Is that clear? Is that clear? So that is why the body size is small, right? And there will be high juvenile mortality. So opposite will be there when it comes to the K strategists, right? The stable conditions, predictable conditions, population size will not fluctuate, reproduction will not be that early, right? So reproduction will be later and slower, number of offsprings will be fewer, they'll be usually of larger size, right? Survival, parental care is more, so survival rate will be more. Done, beta? Survival rate will be more. That's it. Now, obviously, we are living, right? So many populations, so many different populations are living under the same set of environmental conditions. So they will also struggle for the resources. They will also fight for the same resources. They will sometimes they'll help each other. They'll harm each other. So all that things comes under the population interaction. So here they are saying that there is no such habitat, right, where a single species is living. The minimal requirement is one more species on which it can feed. This is what we need, right? If you talk about us, we need the plants. If plants will not be there, who's going to make the food? How will we get the oxygen, right? So plant species, plants, you know that they are autotrophic. They can make their own food, but still they cannot survive alone. Why? Because they need soil microbes to break down the organic matter in the soil and to return the inorganic nutrients for absorption. So plants, those who are autotrophic, cannot live by themselves, right? They are also having the conditions there. So, and then how will the plant manage pollination if there will be no other species? So it is obvious that in nature, animal, plant and microbes, they do not and they cannot live without each other in isolation. They have to interact with each other. That's how they make the biological communities. So even in minimal communities, you will find many linkages, right? So inter means in between. Specific interactions means interaction between two different species, right? So when interaction of population of two different species is there, that is the interspecific interaction. So this interaction can be beneficial, but if it is beneficial plus, right? If it is detrimental, means if it is harming each other, that is negative. And if even it is neutral, right, it will go for 0 for the neutral. 1. This is what you need to know. So this table is important. Now in NCERT, right, in NCERT they don't give this example. We will discuss it. It was there in old NCERT. Rest all the examples are there. So mutualism, best example that you all have studied is lichen. You all remember about mycorrhiza. Right, so competition in which both are getting harmed beta. Predation, predator will be get the benefit, prey population will decline. Parasitism is there again, plus minus. Commensalism in which one is getting benefit, another one is neither benefited nor harmed. Amensalism, one is harmed, another one is again neutral. So this is what you need to know. So the very first thing that they have given us is the predation. So what sort of relationship it is? What sort of relationship it is? So it is beta plus minus sort of relationship. Predator will get the benefit and the prey population obviously they'll be harmed. So let's suppose what are they saying? What would happen to all the energy fixed by autotrophic organism if community has no animals to eat the plants? So you know that we have the trophic level. Just first trophic level pe we have the producers. We know it very well. Yes or no? Producers are there. Then comes the primary consumers. We all know it very well, beta. We all know it very well. So producers means, let's suppose you are talking about plants. So primary consumer, you will talk about the herbivores that are going to feed on that plants. Then you will go for secondary consumers that will feed on these herbivores. So we can also call them as primary carnivore. And then you have tertiary consumer, and then you will be calling them as secondary carnivore. So ultimately, what am I trying to show you? Then there will be the top consumer or your tertiary carnivore. So this is how the energy will flow, and it is the 10% of energy which will pass to the next trophic level. And it is important, the energies they will pass like that. Imagine if herbivores, they will not feed on plants. Right, how the primary carnivore they will get the food. Herbivores are very important. Why? Because carnivores cannot directly eat the plant, so herbivores are the one that are converting this, right, they are making this biomass available for the primary carnivore as well. So this flow in the nature is important. So they are saying ki predation is a nature's way. This is a wonderful line. I love this line. Please pay attention. Ki predation as nature's way of transferring to higher trophic level the energy fixed by plants. What is predation? So in predation, what is happening? It is the way of nature. Yeah, it is nature's way, right? It is the nature's way of transferring, right? It is the nature's way of transferring the energy to higher trophic levels, the energies which is fixed by the plants. So that is how it moves. So predation, this is the benefit of predation. It is helping for us to pass the energy from one trophic level to another. So that's what you have to keep in your mind. So when you think of predator and prey, right, beta, right? So just say, let's suppose you are talking about the tiger and the deer. Right, but a sparrow which is feeding on, generally this is what we call as predation. But if a sparrow is feeding on what? If a sparrow is feeding on the seed, right, on a plant also, that is also not less than predation. So this is something we need to know. So animals eating plants, that is your herbivores, right, they are in a broad ecological context, not very different from predators. So this is also not something which you cannot call as predation. Is that clear? Is that clear? So besides means in addition to. So in addition to conduits means channels. Conduits means what? It means channels. So besides acting as conduits for energy transfer across trophic level, like, so here we have just justified ki predation is very important because it is the nature's way of transferring the energy from one trophic level to another. Why predation is important? Because it is the nature's way of transferring the energy from one trophic level to another. So predation is something very important. So we are saying in addition to act as a channel for energy transfer, they are also having another important role. So predators, they keep the prey population in control, right? Right. Predators, they keep the prey population in control. Are you getting my point? Are you getting my point? Done, beta? Done, beta? Sure? Sure? Any doubts here? Any doubts here? Done. So they keep prey population under control. जैसे foreign examples, it is very common beta, it is very common to have fight with our siblings, right? So we fight, and let's suppose if our mother, father, they'll not be there. So we can just fight each other and we can just kill each other. Sometimes we are that much furious. So mama, papa, they do what? They keep a check on that. They keep a check on that. So it is like that. Ki prey population means individuals of same species, because they have the same resources that they want. They can also fight with each other. They can also destroy with each other. They can also kill each other. But predator population will make sure ki even prey population should be there in a limit. So this is what they are saying. Ki predators, they also keep prey population under control. That's important. Predators, they also keep prey population under control. But for predators, prey species could achieve very high population densities and cause ecosystem instability. Prey species could achieve, what are they saying? For predators, prey species could achieve very high population densities and cause ecosystem instability. Matlab prey population, if it will be at very large density, that is also not good, because in nature there should be a balance. So this is the example they are giving. Let's suppose there is an exotic species, a species which is not from a particular area. You are introducing a particular species in a particular area. So here, because this exotic species is not having its natural predator, so it will grow excessively. You can see that when certain exotic species are introduced into a geographical area, they'll become invasive. They will become invasive and start spreading fast, right? So certain exotic species, when certain exotic species are introduced into a geographical area, they become invasive and start spreading fast, because the invaded land doesn't have its natural predator. So exotic species, what are they doing? Right, they are becoming invasive. Why? Because they don't have their natural predator, so they are growing excessively, right? So that is also creating an imbalance. So just to maintain that, it's important to have the prey population predator as well. So next example is of prickly pear cactus, Opuntia. Next example is of prickly pear cactus, that is your Opuntia. Right, that is Opuntia. So it was introduced in Australia. So beta, examples are important. Examples are important. So it was introduced in Australia in early 1920s, caused havoc by spreading rapidly into millions of hectares of rangeland. So finally, the invasive cactus was brought under control only after a cactus feeding predator, a moth from its natural habitat, was introduced. So biological control methods adopted in agriculture pest control are also on this particular thing. So when it comes to the predators beta, so the lines that I am highlighting, they are important for assertion and reason. They are important for statement based questions as well. So predators also help in maintaining species diversity beta in a community by reducing the intensity of competition among competing prey species. So yes, predators, they will keep that population size of prey, they'll maintain the population size of prey population as well. Plus, right, they will, because if prey population will be too much, they will also struggle with each other. So it is maintaining that. So this is important beta. This is important. Is that clear? Is that clear? Sure? Beta, sure? Okay, done. So what is the name of this predator here? This is Cactoblastis. So you can just simply write the examples, okay? Next example that they are giving us, right? So they are saying in a rocky intertidal communities of the American Pacific coast, the starfish Pisister is an important predator. Matlab in that intertidal areas, in the American Pacific Islands, American Pacific coast, the starfish, what is the name of starfish? Pisister. It is an important predator. So first of all, if I have to take the notes from this particular part, what am I going to write? I'll write Pisister. What will I call it? I am going to call it as a predator. It's a predator. And what is it? It's a starfish. It's a starfish. So in the field experiment, when all the starfishes were removed from that intertidal areas, more than 10 species of invertebrates, beta, right? More than 10 species of invertebrates, they became extinct within a year. Why? Because they'll start struggling with each other, right? Because of this interspecific competition. So these invertebrate species, they will start struggling with each other. So this is the second example that you need to underline. Now, third example is the predator in nature has to be prudent. This is the third thing that you have to underline. Prudent. Matlab, in Hindi we call it as viveki, like that predator should have patience. Like it should not be like a predator is like, today I am in the mood, I will destroy all the prey. No, that is also not good, because it has to maintain that, right? We cannot just destroy a species completely. Okay, they all are required. So the point here is predator in nature, they are prudent. So prey species have evolved, right? They are prudent, and even beta prey species have evolved various defense mechanism. Right? No doubt predators are there to feed on prey, but prey population is also having the ways by which it can protect itself from the predators, right beta? Like insect and frogs, they are cryptically colored, camouflaged to avoid being detected easily by predators. So that's what you need to remember. So cryptically colored means camouflage. So this is important. This is important. Baki, some are poisonous, therefore avoided by the predators. Right? Some are what? Some are poisonous. So the camouflage means blending with the surrounding, right? Just say, let's suppose there is a stick insect. It looks like the stick. So its predators will not be able to recognize whether it is a stick or an insect. Leaf insect looks like a leaf. Are you getting my point? So this is like blending with the surrounding. Just say, let's suppose you are having an organism whose color is green. So in the forest, you won't be able to detect that camouflage it is. So some are poisonous as well. Just they are giving the example of monarch butterfly, which is highly distasteful. Highly distasteful means unpalatable, means something which we cannot eat because it is not at all tasty. So highly distasteful to its predator. So a bird feeds on monarch butterfly, but they cannot. Why? Because it is highly distasteful. So it is its mechanism, because it is having a chemical which is protecting it. Otherwise the bird population will destroy that. Now butterfly acquires this chemical during its caterpillar stage by feeding on poisonous weed. So this butterfly, when it grow, it feeds on poisonous weed. Because of that, it is having a chemical which is making it distasteful or unpalatable for its predator bird. So that's how in nature, if nature is like, nature is there to enjoy, and nature is like there should be a predator that is going to control the prey population. But nature is also like, I should give something to prey as well. Prey should also know how to protect itself. So that's how everything is related. Okay. Next plant, just herbivores. I told you they are also the predator. We cannot ignore that. So nearly 25% of all insects are known to be phytophagous. So what's the meaning of being phytophagous? So phyto, plant, feeding on plant sap and other parts of plants. Is that clear? Is that clear? And plants, you know that they cannot run here and there. They cannot protect them. So they have other ways. Just in case of plants, morphological and chemical defenses are there. Just for an example, they have thorns. Example is acacia, cactus. Most common morphological means of defense. Why do they have thorns? Why do they have these things? Because these things will protect them from their predators. So many plants, they produce and store chemicals that make the herbivore sick. When they are eaten, inhibit feeding. Right, beta? So just say here, the example that we have is there is a weed, Calotropis. Right? It is growing in abandoned fields. So it forms highly poisonous cardiac glycoside, right? So whenever cattle or goats, they'll feed on that, they'll get sick. Okay, beta? So other chemical substances are also there, just nicotine, caffeine, quinine, strychnine, opium. So I don't know whether you know it or not. Quinine, you know it is used to treat malaria. It used to treat malaria, quinine. Do you know that? Do you know that opium we have studied from the poppy plant? From where do we get it? From the poppy plant, isn't it? Done, beta? Done? So it is also highly toxic, colorless, obtained from a plant, obtained from the plants beta. So what is its role? What is its role beta? So in this case it also act like what? It basically act like stimulant. Is that clear? Okay, so primarily it is used as strychnine. So whatsoever is in NCERT, you should know that as a pesticide. Okay, so its small doses can be stimulant. Small doses act like stimulant that stimulate a system. Okay, so these examples are important. Next is competition. So competition में this is Darwin. Darwin spoke of the struggle for existence. You know that if an individual is fit here means a reproductive fitness, right? They'll survive there. They'll give birth to the better individuals. So here what's the point? That Darwin spoke of the struggle for existence and survival of the fittest in nature. He was convinced that interspecific competition is the force for organic evolution. So what will I conclude here? Interspecific, two different species, they are fighting with each other. Interspecific competition is a potent force in organic evolution. That's what you have to remember. Okay? So it is generally believed that the competition occurs when closely related species compete for the same resources that are limiting. When the competition will occur? When the closely related species, the species which are so close to each other, they compete for the same resources are limited. Matlab, you are talking about the species. Obviously, they have certain needs. They'll compete for the same resources. Here you are talking about the closely related species and resource if it is limiting, right? But this is not entirely true. As per that, what are they saying? Ki competition will be there. When closely related species, they will struggle for same resource and the resource is limiting, competition will be there. But next they are saying ki sometimes even totally unrelated species could also compete for the same resource. That's true. That's true. Just let's say, right, on a plant, like you want to eat a fruit, right? Let's suppose oranges are there, yeah, mangoes are there. There must be a bird, yeah, insect that is also feeding on that. So you are so unrelated, you need a same resource. Same is the thing here. So here they are giving us one example, right, that in some shallow South American lakes, that visiting flamingos, you know, that, kind of pinkish birds, and the resident fishes and flamingos. One is a bird, one is a fish, but they are fighting for their zooplankton. Why? Because both are their food. Is that clear? Both. For them, this is the food. Zooplankton is their food. That is why. So, secondly what? Secondly, they are saying that resources need not be limiting for the competition to occur. Just earlier it was believed that if resources are limiting, then the competition will occur, right? So there are pointers that you need to rule out. Number one, the competition will be there in the related species, and when the resource is limiting. Then we got to know it's not always mandatory that the species need to be related. Sometimes in unrelated species also competition is there. Sometimes in unrelated species also, beta, Saharika, competition will be there. Second point is they are saying कि resources need not be limiting for the competition to occur. Matlab, it's not mandatory that resources should be limited only. So we have one more example, that is the interference competition. Interference competition. Just for an example, I'll give you an example. Just let's suppose you are eating something, है ना? You, whatever is your favorite fruit, whatsoever it is, for your generation, it might be pizza, burger. Just I am a parantha person. I love paranthe. So basically, let's suppose you have unlimited supply of burgers, right? And you are like, chalo, theek hai, let's eat. Let's eat. So when you are eating alone, you are eating at your own pace, you are enjoying. Now there is one more cousin of, right? Now resources are limited, the resources are limited, but that person is eating at a faster rate. You are eating very slowly. So this is a kind of example of interference competition. So here if the resources, they are unlimited, still right? Because one species is superior. Yeah, one species is having better ability to eat, to get it, than the another one. So that is also getting the benefit. So in interference competition, which example are they giving us? In interference competition, which example are they giving us? That the feeding efficiency of one species might be reduced due to the interfering and inhibitory presence of other. Matlab, you were doing good when you were alone, but now somebody else is there, right? So even if resources are abundant, but one species is having less capability than another. So that is how these two things are related to each other. Is that clear? Is that clear? So their competition is best defined as a process in which the fitness of one species, which is measured in terms of its R, that is the intrinsic rate of natural increase, is lower in presence of another species. So whenever I will say competition, it is between two same species. It can be in between different species also. It is in between different species. It can be in between same species also. So what you have to remember, when there is the competition, right, the R of one species will be lower than another. The one which is having the lower R, matlab other species will be better. Okay, so first thing, in competition, what you concluded, that resources need to be limiting, and the competition is there in between two closely related species. But then we read that it is not mandatory that the species need to be closely related. It can be in between the unrelated species also, right? We discussed the example of flamingos and the fishes. They were struggling for the zooplanktons. Third point that we learned is ki even if resources are unlimited, right, the competition can be there. The example for that is interference competition. So in that interference competition, what we learned, what we discussed in that interference competition, it was very simple. In the interference competition, this is what we discussed, that even if food and space is unlimited, one species is having the better feeding capability than the another one, right? So this is also the example of competition here. Now the next and the important one is, right, just there is a lab experiment, beta, that is also PYQ, right, that is also PYQ. So in that lab experiment, as Gauss and other experimental ecologists, they were like, when resources are limited, the competitively superior species will eventually eliminate the other species. But so this is competitive exclusion, which is, but in nature we do not have this. So who gave the, what kind of questions can come from this part? So competitive exclusion principle, that's the word we have. Who gave that? Gauss. So here they are talking about competition, and when food and space is limited, when food and space is limited, when food and space here is what? When food and space here is limited. This is what we have. Food as well as space here is what? It is limited, right? It is limited, right? When food as well as space here is what? It is limited. So as per this, superior species eliminate inferior one. I'll give you the example of interference competition as well. Right. So first I'll talk about this. So superior species will eliminate inferior one. But what are we saying? That in nature we don't see such examples. Right. We cannot always say, na beta, we cannot always say in nature, na, ki one species has eliminated another. This is also not good. Don't you think so? This is also not good. Don't you think so? Don't you think so? That is also not good. So in nature, rather, what do you see? You see the resource partitioning. So here they are giving the example that strong and persuasive circumstantial evidence does exist, however, in some cases. Matlab, this is not always conclusive in nature कि one superior species will eliminate another. But yeah, some evidences we can see. Just see, this is the example they are giving us. Just this Abingdon tortoise in Galapagos Island. It became extinct within a decade after goats were introduced on the island. So what is the example that it is giving us? That Abingdon tortoise in Galapagos Island, Abingdon tortoise in Galapagos Island, what they just said, they became extinct within a decade after goats were introduced on the island, right? They became extinct, right? Within a decade after goats were introduced on the island, apparently due to the greater browsing efficiency of the goats. So they were having the better efficiency, another one was having the lesser efficiency, so they just got extinct. So another evidence for occurrence of competition in nature comes from competitive release. So anybody who can tell me about this? Yes, anybody who can tell me about this? Yes, beta, quick. Yes, please. And please pay attention. Done. So beta, another evidence is the competitive release. So what is the meaning of competitive release? Just say, let's suppose of one species, it is growing. Why? Because it's it's a competitive species, it is eliminated. So this is the meaning here. So you can write down, it is the increase in population size of a species. Hanji. So it is the increase in population size of a species. It is increase in population size of a species when population size of a species, or I would say in its population size, in its distribution, in its abundance of a species when its competitive species is removed. So this is what competitive release is. Is that clear? So its competitive species, it will be removed. So if it is the increase in population size, comma, distribution of a species when it's in its distribution, in its abundance, when its competitive species is removed. Is that clear? Is that clear, beta? Done. And abundance of a species when its competitive species is removed. Understood? Understood? Chale, next part. So let's move to the next part. So a species whose distribution is restricted to a small geographical area, right? Why? Because of the presence of competitively superior species will expand better dramatically when its competing species is removed. So that is what the competitive release is, right? I told you already that one species will grow, flourish, its distribution will be more, its abundance will be more. Why? Because you have removed its competing species. Just let's suppose you are scared of your father or mother, whosoever can be, right? You are scared of your father, right? When your father is not there, right? You are just roaming here and there, you are enjoying. Once that person will enter, you are again like, oh my God. So it is something like that, right? It is something like that. So now there is one more experiment which is by Connell. So Connell's elegant field experiment, right? Connell's elegant field experiment showed that on rocky sea coast of Scotland, on the rocky sea coast of Scotland, the larger and comparatively superior barnacles, beta. First of all, you have to remember larger and superior barnacle. Balanus dominates the intertidal area and exclude the smaller barnacles, that is Cathamelis, from that zone. So in general, herbivores and plants are most adversely affected by the competition than the carnivores. Now listen to me. How can you remember that? Just say Balanus and Cathamelis is given. So from B you can remember big. So you can remember this is actually the bigger one, means actually the dominating one. Because sometimes in paper when they ask the examples, we get confused. So barnacles, if you don't know, if you ever visited beaches, so you'll see, right, with that, you know, with that stones, sometimes with the stone, sometimes with that like in that areas you see some structures. I'll show you the picture also. So Balanus will be the dominating one and Cathamylus will be the smaller one. So that's what you need to keep in your mind. So here they have given us, right? So we are about to finish it. Let's speed up, beta. Let's speed up. So another one is Gauss competitive exclusion principle. So as per that, when two closely related species, when they are competing for same resource, I told you this part already. When two two species which are fighting for the same resource, they cannot coexist indefinitely. Matlab, he made it very clear that whenever you will talk about the two closely related species, so what is the first condition which I need to emphasize? He said two closely related species. Then he said they are competing for same resource. Then he said can't coexist indefinitely. The inferior one will be eliminated by the superior one. And when this condition will apply, when the resources are limiting but not otherwise. So as per competitive exclusion principle, right, if there are two closely related species, if they are struggling for the same resource, the one which is superior will eliminate the inferior one, right, when the resources are limited, right bache, right? But more recent studies do not support such gross generalization. Matlab, there are studies which are not supporting this generalization. Why? Because in nature, so while they do not rule out the occurrence of interspecific competition in nature, they point out that coexistence is promoted in nature, right? Nature is not like exclude this one. Nature is like one should coexist. Okay, जैसे many years ago, people they were not able to imagine that one can study online. Then online came due to COVID. Matlab, online was there earlier, but it got more hype in that COVID time period, and then people were assuming this that online will when the offline institutes they'll open, online will go away, yeah, online will not be there. So now you know that they are coexisting. So it is like that. So coexistence is promoted by nature. So here they have given us one example of resource partitioning. Just let's suppose, beta, you are sharing your home with your sibling, right? It's not like that even if you don't like them, we can kill them or we can send them away. No, you have to live with them, na? So just let's suppose if you struggle for your gaming time, yeah, for we used to struggle for watching TV, right? So we cannot just destroy each other. Yeah, we cannot throw each other away. So what is the best way? Ki theek hai yaar, from 12 to 2 I'll watch, from 2 to 4 you will watch. When you will watch, I will not disturb you. When I will watch, you will not disturb me. Resource partitioning. So when two species, when they compete for same resource, right, two species, if they compete for same resource, beta, they can avoid or they could avoid the competition by choosing different times for feeding or different foraging patterns. Jैसे example is MacArthur showed that 5 closely related species of warblers, they were living on the same tree, but they avoided the competition. They were coexisting because of their behavioral difference in their foraging activities. So this is about the competition. Next comes the parasitism, beta. So after parasitism, there will be commensalism, mutualism, and then PYQ practice. Chaliye. So parasitism again. This is the relationship. Host will be harmed, parasite will get the benefit. So parasites, you know that, right? They need the free food, free meals. Okay, so parasites, they have evolved the mechanism by which they can survive or they can even ditch the host immune system, right? Defense system. So here, parasitism has evolved in so many taxonomic groups, right? From plants to higher vertebrates, we know that. So parasites, they are evolved in such a way, they are host specific also. Just they can parasite only a single species of host, right? Just there is a particular parasite, a particular virus that need a particular host only, otherwise it won't be able to live. So yes, this is the relationship we see. So both host and parasite, they tend to co-evolve, beta. So host, obviously host defense system will fight against parasite, but if parasite need to live there, parasite will also evolve. Parasite will also learn that how can I avoid the host defense system. Are you getting my point? So this is the kind of relationship that we see. We see the co-evolution there, right? So host is evolving itself so that it can protect itself from parasite. Parasite is evolving so that it can live within that. Is that clear? Is that clear? So if the host evolves special mechanism for rejecting the parasite, parasite evolve the counteract and mechanism to counteract and to neutralize them in order to be successful within the same host species. Now, in accordance with their lifestyle, you know that they are getting the free food and meals, so they just need to learn how to survive there. So they have some special adaptations. So जैसे unnecessary sense organs they will not have, because they don't need to search for the food from the host, they will get it directly. So they should have the adhesive organs like suckers, so that they can attach themselves to the host. So suck hooks and suckers, important parasitic adaptation for endoparasite. This is again a PYQ beta. So loss of digestive system, they are getting pre-digested food. Reproductive capacity should be maximum, they should reproduce, they have to make maximum number. So they evolved such ways so that they can also protect themselves from the host defense system. So life cycle of parasites beta, they are complex. It can have 1 or 2 intermediate hosts or the vectors to facilitate the parasitization of its primary host. Just a human liver fluke, which is a trematode parasite, it depends on. So liver fluke, which is a flatworm, it needs a snail as well as a fish to complete its life cycle. Then malarial parasite, right? I'll give you an example. So malarial parasite, so you have female anopheles there. So female anopheles in malarial parasite is what? It is the vector also beta, the one that will spread the disease, and it is also the primary host. Why primary host? Because it is having the sexual stages of that parasite. And what about human? Human is the secondary host and the one which is getting the disease as well. So this is what we need to know, right? So there are many examples. There are many examples where you see that a parasite, particular parasite, it needs more than one host to complete its life cycle. We have that examples also where parasites, they need only one host. Just for an example, we discuss about Ascaris, which is a roundworm, है ना? That is monogenetic. So monogenetic means that is having a single host. That is having a single host. Is that clear? So digenetic, if 2 hosts are there. Okay, so that's why their life cycle is complex for their own survival. Okay, now they are saying a malarial parasite, that is Plasmodium, needs a vector, that is female anopheles, to spread to other hosts. So majority of these parasites, they harm the host, they reduce their survival, growth and reproduction, and reduce their density. So they might render the host vulnerable to predation by making it physically weak. Now this point that they have mentioned na beta, see this. Do you believe that an ideal parasite should be able to thrive within the host without harming it? Why didn't natural selection lead to the evolution of such totally harmless parasites? Beta, funda is very simple. They are saying ki why natural selection is not making any parasite which is harmless for the host. This is not going to happen because parasitism, this is what we are saying in the parasitism. This is what is there in the parasitism, right? It is what we are saying in the parasitism. It is what we will see in the parasitism, that ultimately a parasite is going to make its host weak. It is going to feed from that host. So obviously, how can you say that ki host will not get harmed due to that? Right, its host will become vulnerable for other disease also. So this is not going to happen. This is not going to happen, that this can be, nature has selected this relationship and parasite is not harming the host. It is the nature of their relationship that parasite will always harm its host. Are you getting my point? Number 2, this mosquito, we are not calling mosquito as the parasite. It is a vector. It sucks our blood, but it is not a parasite. Why? Because mosquitoes, even female anopheles mosquito, they need the blood of the human host for the sexual reproduction, for their eggs development. They are not like we cannot feed on anything else. They will die if they will not get the human blood. They cannot feed on something else. That is not the case. They need this blood for their sexual reproduction. So that's why you are calling them as vector, not the parasite. It's not like mosquitoes are feeding on us only and they cannot survive without us. That is not the case. So these are the things which you need to know. So parasites that feed on external surface beta, they are ectoparasites, just lice on human, ticks on dogs. Many marine fish, they have ectoparasitic copypodes. Now this example is the another important example beta. Cuscuta. What is Cuscuta? Cuscuta, which is also known as total, it is a total stem parasite. It's a kind of yellowish kind of plant beta on the trees. So it's a total stem parasite. It is also known as dodder plant. It is also known as amarbale. It is also known as dodder plant. It is also known as amarbale. Dodder plant or amar bale it is. So it is a parasitic plant, bache, that is found growing on the hedge plant and has lost its chlorophyll and leaves during evolution, during the course of evolution. So it's a total stem parasite. It is also known as dodder plant. It is also known as amar bale. So it is taking its nourishment from its host plant only. It doesn't have leaf. It doesn't have chlorophyll. It is taking whole of its nutrition from the host plant, beta. So it derives its nutrition from the host plant, which it parasitize. So female mosquito is not considered as a parasite. I told you reason already. So this example is important here, right? Dodder plant, total stem parasite. So I can ask you the question whether it is a root parasite or not. So it's a total stem parasite, beta. And endoparasite, you'll know that they live within our body, right? So their life cycle is more complex, right? They, because of their extreme specialization, so their morphological and anatomical features are greatly simplified, beta, while emphasizing their reproductive potential. That is it. Baki brood parasitism, right? Remember Three Idiots movie? So here what is happening? Parasitic bird is going to lay the eggs in the nest of its host bird. Host will incubate them. So with the time period, the eggs of that parasitic bird, they'll evolve in such way that they will look like the egg of the host bird as well, right? This is the brood parasitism. The best example that we study here is of cuckoo, that is quail, right? And crow. So this crow is going to incubate quail's eggs basically. Okay, so with evolution, host egg in size and color, right, it will be like that parasitic bird's egg, and parasite will evolve it in such a way that its eggs will be like the host bird's eggs. So this is what you have to see: brood parasitism, then beta commensalism. One is getting benefited, another is having no effect. This is, let's suppose you are getting clothes of your elder brother or sister because they are not getting fit into it, right? Their height, it will increase, so they are like, we are not getting fit into it, so your mother will give that to you. So you will be like, okay, I'm getting new clothes, but it is not going to harm or not going to benefit your elder one. Okay, so here what is happening in the commensalism, here what is happening, one species is getting benefit, other is neither harm nor benefit. So here the first example, because example based questions are ultimately going to come, orchid growing as an epiphyte on a mango branch. So orchid, when you are talking about this orchid, so we are saying orchid is an epiphyte. Epi means above, phyte means plant. So where is it growing? It is growing on the plant. Why, beta? So it is growing on the mango plant, mango branch. So it is not taking any nourishment from it. It is just using this branch space. So it is not harming mango. Why? Because it is not taking any nutrition or nourishment from that mango. Actually, in this orchid, in its roots, you will find velamen. Right? What is velamen? Velamen is the spongy tissue. What is velamen? Velamen is the spongy tissue. It is the dead spongy tissue, beta. And this tissue is what? It is hygroscopic in nature. This tissue is what? It is hygroscopic in nature. That is, it can absorb moisture from surrounding. That is, it can absorb moisture from surrounding. So it is not taking anything from the host plant, right? It is just using that space. So that is why it is not harming that mango branch, right? And it is having this velamen, dead spongy tissue. Next example, the barnacles on the back of whale, right? So they are just using that space, not harming the whale or the mango plant. Baki cattle egret and the grazing cattle in close association. So cattle, they will graze, they'll feed on that grass. The cattle egret will move with that. Why? Because when the cattle, when they are going to feed on the grass, the insects will come out. These cattle egrets, they are going to feed on that. Okay, so egrets always forage close to where the cattle are grazing, because as they move, stir up and flush out insects from the vegetation, otherwise might be difficult for the egrets to find and catch. Is that clear? Another important relationship, beta, sea anemone. It is having stinging tentacles, na? Sea anemone. It is cnidaria. It is having that nematoblast, nidoblast cells. So It is having that stinging tentacles, so the clownfish will live in that tentacles, right? So if there will be any predator that will reach out to clownfish, so clownfish will get the protection due to these stinging tentacles. So fish is getting protection, right? And animal doesn't appear to derive any benefit by hosting that. Understood? So next is beta mutualism, where both are getting benefit, So the best example is of lichens. So lichens are the pollution indicators, right? Pollution indicators, especially beta sulfur based pollution, especially that sulfur based pollution wherever, right? So lichens, they do not grow, lichens do not grow in polluted areas. So if lichens are growing, it means the area is not polluted. So what sort of relationship it is? Mutualism. So it is having beta algal component. So algal component is also known as phycobiont. You know na, study of algae is phycology. There will be fungal component. So fungal component is also known as mycobiont. Study of fungi, mycology. Right, so phycobiont is there, mycobiont is there. These are the fungal components that we have. So now what's the another point that you need to know here? That see, algae will do the photosynthesis, fungi will absorb, will provide all the essential thing to algae. Algae will make the food, right? So fungi in return is getting food, and algae is getting the food, the observed things from the fungi. So this is the relationship. Okay. So an intimate mutualistic relationship between fungus and photosynthetic algae, but it can be cyanobacteria, that is blue-green algae as well. Another is beta mycorrhiza. So here you know that roots of higher plants. What's that? Here you have roots of higher plants plus fungal hyphae, right? They are in close relationship. So roots of higher plant like your pinus, and for fungus the genus is Glomus. You remember in microbes in human welfare chapter also we discussed that. So fungi, because the roots, this plant is not capable enough to absorb all the nutrients from the soil. It cannot absorb all the nutrients from the soil, right? Roots are not that capable enough. So fungal hyphae will do what? Fungal hyphae will provide it the nutrition, right? Fungal hyphae will provide it the nutrition, right? The plant will start flourishing, the plant will start growing. So this is what we see here in this particular case, right? This is what we see here in this particular case, right beta? So pinus plus glomus, so roots of higher plants plus fungal hyphae, they will come in relationship. So this is the relationship. So even this higher plant will get protection from the root pathogens as well. Okay, so fungi in return is getting a space, getting the food. So that is how this is the thing. So absorption of essential nutrients from the soil, fungi or plant will give fungi the energy yielding carbohydrates. So this is another example. Okay. Baki plants, they need the help of animals for pollinating their flowers, for dispersing their seeds, and animals, they are getting what? They are getting what beta? Rewards or fees in the form of pollen and nectar. So this is also the example here, right bache, right? Now you can see why plant animal interaction often involve co-evolution. So here also you know that plants, they need these animals for the for their pollination, seed dispersal, and animals in return are getting these pollen grains, they are getting these rewards. So here they are giving us the example of the fig tree. So you know that the question was there in 2025. So you know that what we discuss here, we discuss a fig and the wasp relationship. Fig and wasp relationship. Actually this fig, right, that is the ficus species. What's that bache? It is a ficus species. So fig in Hindi you call it as anjeer, hai na? So they are having what? So the fruit that you discuss here na, so the fruit that you discuss here na beta, so that is actually, right, that is actually what? That is actually hypenthodium. Hypenthodium. What is hypenthodium beta? Matlab that fruit that you discuss is actually hypenthodium. So hypenthodium means a special type of inflorescence. Hypenthodium means a special type of inflorescence. Is that clear? It is actually a special type of inflorescence. It is having male flowers, female flowers, and sterile flowers as well. So through the pore, the wasp will enter here, will lay the eggs here, right? Eggs are getting protection, they'll hatch there, and obviously after laying it, it will die. So now when these larvae, when they will hatch, even they will find their way, they will go here and there, they will search for another bee, and meanwhile in this process, they will help in pollination. They will help in pollination, right? So this is how they are dependent on each other. One is getting a safe space to lay eggs for the maturation of that eggs, and another is getting getting the help in pollination. So in 2025 PYQ was there. So statement 1 was saying, beta, statement 1 was saying कि fig is a non-vegetarian fruit. Statement 1 was saying कि fig is a non-vegetarian fruit. Why? Because it encloses these wasp larvae, right? That is why. And beta, when I solved this paper, I marked it as correct, but as per the NTA's answer key, it is incorrect. I'll explain you. Jaise beta, those who are vegan, you know na, vegans, they don't eat anything which is animal based. They don't eat anything which is animal based. There is a difference in being vegetarian or being a vegan. Just I am a vegetarian, but I do take milk, curd, paneer, all that things. But when you are talking about vegans, they don't feed on anything. They don't feed on animal milk. They'll go for almond milk or something, right? So basically, rich people, they can do that. So basically, vegans, they don't eat this fig. Yeah, they consider it as a non-vegetarian fruit, because it is having that these flies, they come from, when they get mature, they come from these fruits. So they consider it ki nahi, in this insects are there, so how can we consider it as the vegetarian fruit? So they do consider it non-vegetarian. So it is kind of debatable. And statement 2 there was saying, in that particular question, right, we will solve it also. Statement 2 was saying कि fig and wasp, they show a mutual relationship. Their life cycle is dependent on each other, which is true. So yeah, fig is a non-vegetarian fruit. As per NTA, they marked it incorrectly. So this is the relationship that you have to understand, right? So a fig species can be pollinated only by its partner wasp species, no other species. So this is important. Then female wasp uses the fruit not only as oviposition. Oviposition means egg laying, but also uses the developing seed within the fruit for nourishing its larvae. But as per NTA's answer key also, these larvae, when they'll grow, so enzymes in the fruit, they will degrade that, so they'll be destroyed. So it is not a non-vegetarian fruit. So wasps pollinate the fig inflorescence while searching for suitable egg laying site, right? These flies, they will move here and there, they'll find a place. So in return for the favor of pollination, fig is offering them, or offers the wasp some of its developing seeds as food, right? Just there will be some flowers from where you will see in that larvae will grow, right? So that will not form the seed, because these larvae are growing in it, they are getting nourishment. So this is what you have to understand here. Still there is any doubt, you can ask me, okay? Okay, baki beta, orchids, you know that. So there is one example of Ophrys. This is something we discuss in sexual reproduction in flowering plants. So this is the example of beta pseudo copulation, false copulation. Yeah, this is what we call as sexual deceit, right? So what is happening? They say these orchids, right? They have beautifully shaped or differently shaped, petals and all. So in Ophrys, there is a petal that looks like a bumblebee. It is having the markings just like bumblebee, right? And during the course of evolution, this flower, right, its fragrance is also just like the female bumblebee. So when male will see that petal, male will not be able to differentiate whether that is a flower or a female. Male will think that it is a female bumblebee. So male will go there for copulation, but it is not doing copulation, it is not performing copulation, rather it is doing the pollination. So it is the sexual deceit. So imagine, nature is wonderful. So what has happened here? So here, like, flower has evolved in such a way, it is just showing, it is also having the fragrance like that. So this is what you need to know. Okay, so bees and bumblebees are there, right? Bees and bumblebees are there. So they have guaranteed pollination. So not all orchids, they offer rewards. Just say Mediterranean orchid Ophrys employs sexual deceit, right? Right, so there is a male bumblebee. So one petal of this flower is having uncanny resemblance to the female in size, color and markings. So male will be attracted here, will think that is a female, so it will pseudo-copulate and it is helping in the pollination. Is that clear? So this is how the co-evolution is. That is how they are dependent on each other. So this is it. This is the summary part. So in the summary, it is clearly mentioned, bacha, that ecology is the study of relationship of living organisms with the abiotic, that is physico-chemical factors, and the biotic factors. So evolutionary changes occur through natural selection at the population level, Hence, population ecology is an important area of ecology. So population, you know, that group of individuals of given species sharing a or competing for similar resources, right? So beta, if you are clear with this particular chapter, you know that you can go for the revision from the summary. Now let's discuss the PYQs and let's move to the next chapter. Okay, let's move to the next chapter then. Okay, done. Chaliye, so let's start. I'm starting the poll. Go for it. Quick, everyone. Hanji, so what is the correct answer here? So I told you, see, this is even simple. So dn over dt Rn, so it is k minus n over k, right beta? K minus n over k. So it is the A which is going to be our correct answer, isn't it? Right? Chaliye, let's move to the next question. Choose the correct statement regarding population interaction between two species. Again, so you can see in this paper also beta, you can expect minimum 3 questions from this chapter, that is 12 marks, right? That is 12 marks, and whatsoever we have discussed, you will get question from that part only, so you can just have a look. Mensualism examples also I would like to discuss beta. Dekho beta, in both parasitism, see, if you will get questions like that, look at the option. In all the options, they are saying in both parasitism and commensalism, only one species get benefited, other is harmed. Do you know that in commensalism, it is not like that? So I'll directly eliminate my 2 options. C and D, B and E is common to both. You just have to figure out D. Read the D. In parasitism, only one species get benefit, other species is harmed. That is true. So obviously B, D, E is going to be true here. So D is going to be my answer. So sometimes by eliminating the options also, you people can answer the question. Next question. Next question here, beta. I'm starting the poll. Epiphytes that are growing on a mango branch is an example of 2025 MCQ. Right, 2025 MCQ. So I'll end the poll early here. What are they saying? Epiphytes that are growing on, right? Epiphytes that are growing on mango branch is an example of which of the following? Epiphyte which is growing on mango branch is the example of which of the following? So again, you know, one is getting benefited, another is having no harm there. So this is going to be the example of what? It is the example of commensalism. It is the example of commensalism. Next question. Who is known as the father of ecology in India? Professor Ramdev Mishra. Professor Ramdev Mishra. Now beta, Verhulst per logistic growth curve. So see, right, these type of questions they repeat in 2026, 2025. So yes, right, at least beta minimum 3 MCQs you can expect in your paper, means 12 marks. Okay, so dn over dt, kaan ke niche kaan. So this is going to be C. Done. So before starting the ecosystem, I would like to specify, and you should also write it, examples of commensalism. So one example is Penicillium fungi and beta bacteria. See, penicillium is going to form antibiotic penicillin. It is not harming this particular fungus, but it is killing this bacteria. This is one example. Second example is black walnut tree and other trees. Black walnut trees and other trees. So this black walnut, it releases a chemical beta that is juglone. It releases a chemical that is juglone. So this chemical will not allow other plants to grow nearby. So it is not harming that black walnut tree, but it is harming others. So these are the examples, right, that you people should know. So next chapter that we are going to start is ecosystem. Is that clear? So again, here also beta, we will stick to the NCERT, and you know that it is not at all lengthy. It is even this one we can even finish in 1.5 hour, and that too by discussing it in detail along with the PYQs. Along with the PYQs, again 2 hours for biodiversity. So that is it. Within 5.5 or 6 hours we can finish that. Okay, so this is a very important chapter. So now, do you have any doubt? So I don't think, do you need any break or not? Is it not required? Not required. Or do you need any break? Quickly tell me in the chat section. It's 2:41. Chalo, let's have a 10-minute break. But 10-minute break, ऐसे तो I'm not interested, but still you can have that. Chalo everyone, let's get ready. 10 minutes break over. So let's start the next part. And what is that? What is that? That is ecosystem. Okay. Let's start. Mr. Ecosystem. Okay. So here from ecosystem, okay, beta, next is what? Next is the ecosystem. So ready? Just 1 minute. I'm looking for something. Okay. Chali. So A.G. Tensley coined the term ecosystem. Who coined the term ecosystem? A.G. Tensley coined the term ecosystem. That's what you need to know, or that's what you need to remember. Who coined the term ecosystem? A.G. Tensley. So what is there? See, ecosystem can be visualized as, these are the things which you need to highlight. Functional unit of nature. What is an ecosystem? Functional unit of nature where living organisms, they are interacting among themselves and with their surrounding physical environment. Okay, beta. This is what we study in an ecosystem. So once again, organism, population, community, ecosystem, biome, and finally there will be biosphere. So obviously the complexity will increase when you move from that organism to the biosphere. So what have I just said? I said that how can we remember the ecosystem? So if I have to ask you the question, what kind of question I can give you? I can simply ask you, dash is the functional unit of nature. Functional unit of nature. So what are you going to fill here? It is the ecosystem, which is the functional unit of nature where living organisms, they interact among themselves and with the surrounding physical environment So when it comes to the ecosystem, right, it varies greatly in size from small pond to large forest, right? So micro ecosystem, macro, mega ecosystems are there. That is how we study them. Natural ecosystem, artificial ecosystems are there. Can you believe that a single drop of water can also exist like an ecosystem? And ocean is also an ecosystem. So what is there? Producers are there, consumers are there. So these are the basics that we all have even covered in our junior grades as well, if you people remember. So many ecologists, they said they regard entire biosphere as the global ecosystem, right, having all the local ecosystems as well. So since this system is too much big and complex to be studied at one time, so what will be done? It will be divided into two basic categories, terrestrial and the aquatic. So basically, as I told you, different types of ecosystems are there: natural, man-made. Okay, terrestrial, aquatic, large, small. This is how you can relate it. Okay, so just say forest, grassland. You talk about forest, you talk about grassland, you talk about deserts. They all are the examples of terrestrial ecosystems, right? Forest, grassland, deserts, they all are the examples of terrestrial ecosystems. So pond, lake, wetland, river, estuaries, they all are the examples here. Now, when you talk about the crop fields, aquariums, they are man-made, right? Man-made ecosystems. So first of all, when you have to look at the structure of the ecosystem. So in order to appreciate the input, right, transfer of energy and the output, what you have to see here, you have to see, right, in order to appreciate, we will first look at the structure of the ecosystem in order to appreciate the input, that is productivity, transfer of energy, that is food chain or web, nutrient cycling, and the output, right? That is degradation and energy loss. So this is what, right? We will first look at these structures of the ecosystem beta in order to appreciate the input, the transfer of energy, as well as the output. So here we will also see beta the various cycles, chain, webs that are created as a result of this energy flow. So these are the things which you have to study. So they will not ask you the question from this part. I will keep highlighting the portion as well. Now, see, in the environment, just say ecosystem, all the species or different populations, they are living in a particular set of environmental conditions. They are interacting also, right? That is basically an ecosystem. So in the ecosystem, yes, we have both components. We will be having the abiotic as well as biotic components, isn't it? Isn't it? So individuals, you know that, right? They will interact with each other. They also interact with their environment, right? There is the exchange of nutrients. There is the recycling as well. So all the things are going to occur here. Is that clear? Is that clear? So let us look at these components in a more integrated manner and let's see how the energy flows. So from this portion of NCERT, you are not going to highlight anything. Now, interaction. This point you should know, कि interaction of biotic, I have repeated it multiple times, interaction of biotic and abiotic components, it results in a physical structure that is characterized for each type of ecosystem. What is there? So interaction of what? Biotic as well as abiotic components. Interaction of what? Biotic as well as abiotic components, it results in a physical structure which is a characteristic of, for each type of ecosystem. Is that clear? Is that clear? So next line is saying what? Identification and enumeration of plant and animal species of an ecosystem give its species composition. So the very first thing that we are discussing here is species composition. What are we discussing here, beta? What are we discussing here, beta? Species composition. Is that clear? Is that clear? So this is how you can just define it, कि they all are, right, characteristics of an ecosystem. So number one, you have already discussed the species composition, right? Number two will be beta stratification. Here you will talk about the stratification. These are the words that you need to know. We will talk about the trophic levels, beta. We will talk about the standing crop, standing state. Is that clear? So all these terms are important, right? Standing crop, what is standing crop? What is standing state? So all these terms are important. Am I clear? All these terms are important. Am I clear? So here you all can see when I am talking about the species composition, when I'm talking about what? When I am talking about species composition, composition of species, so their identification, their enumeration, both you will consider here. You are talking about the animal, plant, all the species. Is that clear? Is that clear? Any doubt, beta? Any doubt? Any doubt? Done? Done? So you have to identify and enumeration means you have to list them. You have to give them the number. So this is what we study in the specific composition. Then stratification. Strata means what? Strata means layer, right? Strata means what? Strata means layer. This is what you have to remember. Right? So stratification is the word here. So here, this is the point which you need to focus, beta. Vertical distribution is there. So vertical distribution of, so this is vertical distribution, not the horizontal. It is the vertical distribution. Please keep it in your mind of different species which are occupying different level is called stratification. What is that? Vertical distribution of different species occupying different levels. Vertical distribution of different species occupying different level is the stratification, right, beta? So trees, they occupy top vertical strata or the layers of forest. Then you have shrubs, second, and herbs and grasses are there. So see, first of all, you are talking about the trees, you are talking about the shrubs, you are talking about the herbs and the grasses. So there is a vertical stratification. What is there? Vertical stratification. So strata in general means layer. So here you are talking about vertical distribution. Am I clear? Next, the components of ecosystem. right, are seen to be function as a unit when consider the following aspect: productivity, decomposition, energy flow, and nutrient cyclic. Now, this nutrient cyclic is deleted from your syllabus, so you have to discuss all the three, and trust me, all the three are the important one. Be it the productivity, like either you will get one question from these three topics or two questions from these topics, that is for sure, right? One question from these topic or two questions from these topics. This is what you people are going to get here. So see this. So to understand the ethos of an aquatic ecosystem, they are giving us the example, right? They are giving us the example of a small pond. They are saying whenever you are talking about the ecosystem, beta, it is something which is self-sustainable. Self-sustainable, it can survive by its own. It will be having the source of energy, then it is going to survive by its own, right? There will be producers that will make the energy, you know, that the energy flow will be there. So now they are saying here that it is fairly a self-sustainable unit, right? Self-sustainable unit, and rather simple example that explain even the complex interaction that exists in an ecosystem. So they are saying when you take the example of a small pond, right, this is fairly, no doubt it is a self-sustainable, right? By itself it will survive, it will do all that thing, and even rather simple example that explain that even the complex interaction, right, complex interaction can also be are also existing here in the aquatic ecosystem. Just say pond is a shallow water body, right beta? All four components we will see here. Abiotic component is water here, right, with having all dissolved and organic and inorganics thing. Rich soil is also there. So here source of energy, your solar input, right? So that will maintain the cycle of temperature, day length, and the other climatic conditions that will regulate the rate of function of the entire pond as well. So autotrophic component here is the phytoplankton. There will be some algae, the floating, submerged, and marginal plants. So what are they trying to show us? They are giving us an example. So basically when it comes to the components of an ecosystem, so in components of an ecosystem, we will discuss the productivity beta. We will also discuss the decomposition, and then what else are you going to discuss? You will talk about the energy cycles, right, and nutrient cycle, right? Energy flow and the nutrient cycling will be there. Energy flow and the nutrient cycling, this is what we study. Now just to simplify these things to us, NCERT has given us the example of a small pond. NCERT is saying in that small pond, abiotic components are there, water is there, soil is there with nutrients, the source of energy, sun is also there, right? So this is what we have when you are talking about the inorganic things. Organic things mein, first of all, we talked about the producers, jaise phytoplanktons. What are phytoplanktons? Planktons, something which are freely floating, which passively float with water. When we define planktons, what do we call them? So in case of planktons, we say this very simply, that they passively float with water. Passively float with water current, right? They passively float with water current. Is that clear? They passively float with water current. And you have the word phytoplankton. So plant is the word here. So the these organisms which are passively floating with the water current, right? They are passively floating with the water current, plus they are autotrophic. They can make their own food, that are phytoplanktons. Okay, beta? So they are also there. Some algae are also there. Some plants are also there. Now, when it comes to consumer, there will be zooplanktons that are going to feed on that. There will be small fishes, large fishes, and here you will also talk about the decomposers like fungi, bacteria, and flagellates at the bottom of the pond. So this system performs all the functions of an ecosystem and of the biosphere as a whole. It is having the source of energy also, it is having something that is going to make the food, it is having the flow of energy is also there, recycling is also there, decomposition is also there, right? So what is decomposition? The inorganic so there will be conversion of inorganic into organic material also with the help of energy. First of all, this will be done by autotrophs. They are converting inorganic into organic. This is not decomposition, this is autotrophic. Jaise photosynthesis, CO2 plus water, you are making plants are making glucose from that CO2 and water. So inorganic things are getting converted into the organic one. Who's going to do that? Autotrophs. So if I have to frame a question from this particular line, so I will say that autotrophs are the one that will convert organic substance into the inorganic. True or false? False. They are the one that will convert inorganic substances into the organic one. So who's going to consume that? Heterotrophs are going to consume that. Then decomposition will be there. Decomposers, bacteria, fungi, they will be there. Then mineralization of this dead matter will be there. Why? So that it can be reused by autotrophs. So it is a complete cyclic process also, beta. Plus here you will see it is self-sustainable. So there is a unidirectional movement of energy. Energy will always move in a single direction here, right, towards the higher trophic level. I don't know what is the issue. There is a fly who's just roaming here and there, right? Dekha? They're not cleaning our studio. So there is a fly which is roaming here and there. We'll throw it out. Allow me some time. So what other thing that we need? A constant input of solar energy, right, to function and to sustain. Beta, if somebody will ask you, if somebody is saying ecosystem can work without the source of energy, no, the source of energy is required. Because we will see, right, there will be disorderliness and all, laws of thermodynamics. We will see, we will study so many things here. So one thing is clear, the source of energy should be there, right? The source of energy should be there. This is the basic requirement. Now, primary production, this is what they are calling. So this is an important topic. This is another important topic, beta. This is another important topic. So primary production is the word. So primary production is the amount of biomass or organic matter produced per unit area over a time period by plants during photosynthesis. So what do we have here? What do we have here? It is not productivity yet, it is the production. Production is simply saying amount of organic matter, yeah, biomass, which is synthesized in a particular time period in per unit area by the plants, because they are the autotrophs, isn't it? Your plants are the, dekha this fly. So these plants are the autotrophs, they'll get the solar energy. You know that we are calling them as producers as well. So they are the one that are going to convert the solar energy into the chemical energy. What will they do? They'll convert the solar energy into the chemical energy. This is what you will see. From CO2 and water, they are going to make these carbohydrates. So that is what you have to see. Moreover, you can see they are converting one form of energy into another form. So they are also the transducers. So what are transducers? That convert one form of energy, into another. That convert one form of energy into another. This is what you have when you talk about the transducers. So source of energy is required, so they will make the biomass. So when you are simply talking about the amount of production of biomass, you are talking about the amount of synthesis or production of biomass, then simply production. When you will talk about the rate, at what rate it is happening, that will be productivity. Are you getting my point? In production, you are simply telling me, ma'am, in this time period, you know what I have studied, right? I have studied, right? I was sitting, I studied for 10 to 15 hours, right? I studied for 10 to 15 hours. Just I told you in 2 days you have to study. You are like, yes. Yes, ma'am, I studied there. Now I'm asking what you guys have studied. How many chapters you have covered, right? In 2 hours, how many chapters you have finished? In 3 hours, how many chapters you have finished? I'm talking about your rate as well. At what speed you were studying. So this is the thing which we need to remember here. So primary production is what? It is the amount of biomass or organic matter. It is the amount of biomass or organic matter produced per unit area over a time period by plants during photosynthesis. It is the amount of biomass or organic matter which is produced per unit area over a time period by plants during photosynthesis. Just in terms of weight, gram per meter square, right? Energy, kilocalorie per meter square is the units. These units are very important. Are these units important? They are very important. Now, again, that line that I told you also, rate of biomass production. When you are simply saying biomass production per unit area over a time period is production. Rate of biomass production is called productivity. Rate of biomass production is called productivity. What is it? Rate of biomass production. So it is expressed in gram per meter square per year or kilocalorie per meter square per year to compare the productivity of different ecosystems. Okay? So what do we study here? GPP and NPP. Beta, in simple language, I'll tell you. Just say, let's suppose this is the plant. it is making biomass. ठीक है, the total biomass that it is making is my GPP. What is GPP? This is gross primary productivity. This is gross primary productivity. This is what GPP is. What's that, bacha? It is gross primary productivity. Jैसे it's like, you can take the example, it is like your total pocket money. Let's suppose you are getting 20,000 from your parents. You're 20,000 from your parents. So that 20,000 is going to be your GPP. That 20,000 is going to be your GPP. Now, what is the next thing? Now, from these 20,000, you will spend, let's suppose 10,000 for your stay and food. Rest 2,000 for books, 3,000 for movie dates, coffee dates, this and that date. So you, let's suppose you spend 15,000. So you are left with 5,000, isn't it? Isn't it? So this, your expenses, here we are calling it as R, right? Loss by respiration. Because plants, no doubt they are the autotrophs. No doubt they are going to synthesize the organic food. Indeed, plants, they are what? They are the autotrophs. They are going to synthesize the organic food, but they will also utilize that for their own metabolism also, for keeping them alive also. So that is what you have to understand. That is what you have to understand. So here, right here, this is what we have to keep in our mind. So this is the loss due to the respiration. So whatsoever is rest, this is your NPP. Your savings are basically NPP. That's how you can study, because your savings are something that you can offer to your friend. So this NPP, your NPP, let's suppose your friend is having no money at all. So your NPP will be secondary, will be, this is available for the next trophic level. So it is basically the secondary productivity, right? Matlab it is basically, it will be the one which is available for the next trophic level. So it will be gross secondary productivity there. So this is what we need to know. This is how we understand that. So GPP, what is that? Right? GPP, gross primary productivity. What's that? Gross primary productivity of an ecosystem is the rate of production of organic matter during photosynthesis. So it is rate of production of organic matter during photosynthesis. Is that clear? So it is the rate of production of organic matter during photosynthesis. So this is what GPP is. So GPP will be utilized by plants in respiration, beta. है ना? है ना? Like plants also, they need to carry out their metabolic activities, na? So GPP minus respiration loss. GPP minus respiration loss will give you NPP. That's what you need to remember. Will give you NPP. That's what you need to remember. Is that clear? So NPP is what? NPP is the available biomass for the consumption to heterotrophs, right? The one which is going to feed on that, it is for them. So it is like this. Beta, 1 second. Okay, so what will be there? So now herbivores, yeah, decomposers, whosoever is going to feed on that plant. So this is what we are saying, ki available biomass for the consumption to heterotrophs, right? It is basically the NPP. So it is the NPP that will be available to the next trophic level. Are you getting my point? It is the NPP that will be available to the next trophic level. So secondary productivity is what? It is the rate of formation of new organic matter by consumers. So this NPP is available to next trophic level, right? This NPP is available to next trophic level. So next trophic level is going to show us the secondary productivity. It is not secondary primary productivity, rather secondary productivity. And one thing that you have to remember is, it is the 10% of that will pass to the next trophic level. It is a fact which you have to remember, okay? So it is a fact which you have to remember, okay? Done? Done? So next is primary productivity. Now it depends on what? Obviously, for different ecosystems, it is going to be different. Some are having what? Some are having, you can say, they will be having the more productivity, just your coral reefs, right? Your coral reefs, this is what you need to know, right? In deserts, the productivity is going to be lesser. So primary productivity depends on the plant species inhabiting a particular area. on the environmental factors like availability of nutrients, photosynthetic capacity of plants. So this is what we have. So in different ecosystems, the primary productivity is going to be different. Do highlight this part, beta. Do highlight this part, that annual net primary productivity of whole biosphere is approximately 170 billion tons. It is the dry weight of organic matter, right? You check the dry weight. Why? Why dry weight? Why don't we consider the wet weight? Because then the seasonal fluctuations will be there, right? Seasonal fluctuations, like water amount, it changes with the season. So to avoid that seasonal fluctuations, dry weight is considered basically. What is considered, beta? Dry weight is considered basically. So of this, despite occupying about 70% of the surface, the productivity of the oceans is less, beta, 55 billion tons. And land will have the more productivity. So this is something that you need to know regarding the productivity thing, right? This is something that you need to know regarding this productivity thing. I hope this part is clear. I hope this part is clear. Yes, everybody. I hope this part is clear to all. So, just your coral reefs, tropical rainforests, they are having more productivity. Is that clear? Yes? Done? Any doubt? Done? So, जैसे your tropical coral reefs are having high productivity, beta. Your tropical rainforests, they are having high productivities, beta. Your even estuaries, they are having good productivity. So deserts, right, tundra, grasslands, comparatively, they will be having less. So even in estuaries, beta, right, when you talk about the estuaries, they are nutrient enriched. They are nutrient enriched. There also you will see higher productivity. Is that clear? Higher NPP. Okay, higher NPP. This is what you are going to see here. Is that clear? Done? Chaliye, let's move to the next part. Why in the oceans you see less productivity? Anybody who can answer this question? Why in oceans there is less productivity? Why in oceans? Yes, everyone, quick. Oceans, they occupy, right? They occupy about 70% of the surface. But when it comes to their productivity, it is just 55 billion tons, right? Why is it so? Why is it so? Quick. Dekho beta, it is very simple. When you talk about the oceans, you have the phytoplanktons as the producers. So when you talk about the oceans, surfaces will not have that good high nutrients. Na? Nutrients will be there in the deeper layers where your benthic organisms are there, right? So nutrients are not available. Nutrients are not available to these phytoplanktons, the nitrates, etc., which they need. The surface water is not having that nutrients. In the oceans, if you think that deep layers of the water and the surface layer, they get mixed thoroughly, something like that. No, that is also not the case. And in the deeper layers, even the light will not penetrate. Are you getting my point? So nutrients are available in the deeper layers. So these are the factors, right? These are some of the factors which basically decreases the productivity in the case of oceans. Is that clear? Now, next point they are talking about is earthworm. What is an earthworm? Belongs to phylum Annelida. Belongs to phylum Annelida. Also the farmer's friend. And earthworm is hermaphrodite. Earthworm is bisexual, farmer's friend. Why? Because it is also act like a decomposer, beta. It help in the breakdown of complex organic matter as well as in loosening of soil. So how these decomposers help? They break the complex organic matter and also the loosening of soil. And do you know vermicomposting? जैसे वर्मी कंपोस्टिंग में there are some species of earthworm which are used beta, and you can use your kitchen waste and all that type of natural waste, right? These earthworms, they will feed on that, will convert that into the compost, which is eco-friendly, which is good, which is even decreasing the pollution. So this is what you need to know, right? Vermi composting is also there. So breakdown of complex organic matter as well as the loosening of soil, breakdown of complex organic matter as well as the loosening of soil, it will be done by what? It will be done by these decomposers. So decomposers are the one that will break beta complex organic matter into inorganic substances. So I would like to highlight this part again. If you talk about the autotrophs, bache, they convert inorganic substances into organic one. That's the thing that you have to remember. Autotrophs will convert inorganic into organic one. But when you talk about the decomposers, what these decomposers will do, bache, these decomposers, they break, right? Because they will break organic substances, you can say that, into inorganic one. So this can be confusing. So if you ever get confused here, always keep the example of photosynthesis in your mind, where carbon dioxide and water is getting converted into the glucose, which is organic in nature. So that is how you can relate that. So decomposers will do what? Right? Decomposers will do what? They'll convert organic into inorganic, so it's doughy. Right? Decomposers will convert organic into inorganic, so it is doughy. So that's what you have to remember here. Is that clear? So decomposers break down the complex organic matter into inorganic substances, just like CO2, that is carbon dioxide, water and the nutrients, and this is basically the decomposition. Am I clear? So dead plant remains, right? Dead plant remains, that is your detritus. Just dead, that is known as detritus. Dead plant remains, be it the leaf, be it the roots, be it the flowers, bark, whatsoever it is. Even the dead parts of animals, fecal matter, they all make the detritus. So what is detritus? This is what you can write down. So dead organic matter is detritus, which is the raw material for decomposition. So detritus is what? You're talking about the dead organic material, right? Dead organic material, which is a raw material, for decomposition, That's what we need to know. It's a raw material for decomposition. Is that clear? So dead remains of animals, including the fecal matter, they constitute the detritus, beta. They constitute the detritus. So it is the raw material for decomposition. So here I am writing it as well. So important steps here will be fragmentation, leaching, catabolism, humification, mineralization. So beta, these terms individually you should know, right? Just fragmentation, you're breaking something into parts, into fragments. Leaching, then it will be absorbed by the deeper layers of the soil. Catabolism, breakdown, humification and mineralization. So each and every term we need to understand here, we need to discuss here. Is that clear? Yes beta, is that clear? Very good Saharika, Mr. Clear Shots. Neha is here for chit chatting. Okay Sadhya. Chaliye, so next is Manav. So bacha, detrivores. So detritus is the raw material. It is the raw material for decomposition. Detritus is what? It is the dead organic matter. So it is basically the raw material for decomposition. So detrivores are what? Right? Just say example is earthworm. Detrivores are what? Example is earthworm. So break down detritus into smaller particles. What will it do? It will break the detritus into smaller particle. It will break the detritus into smaller particles, beta. So this is the fragmentation. It is breaking that detritus, dead organic matter, into the smaller particle. This is what we call as fragmentation. So by the process of leaching, water-soluble inorganic nutrients go down into the soil horizon and gets precipitated as unavailable salt. Very important point. Now what I need to highlight here, I am talking about leaching. What is happening in leaching, beta? First word that should be clear to me, it's water soluble. It's not water insoluble, it is water soluble. So water soluble inorganic nutrients. Water soluble inorganic nutrients. जैसे in detritus, it's DOI, DOI. Organic substance decomposes will break. In decomposition it's DOI. Decomposes will break organic substances into the inorganic one. Organic into the inorganic one, number one. Fragmentation mein they are going to break it into smaller particles. Then the word is leaching. In the leaching, what am I saying? Water soluble is the key word here. And water soluble inorganic nutrients, because first of all, organic substances will be converted to inorganic one. So the one which are water soluble. So highlight this particular word, beta. Highlight this particular word. Water soluble inorganic nutrients. They will go down into the soil horizon and get precipitated as unavailable salts. So water soluble inorganic substances will pass to the deeper layers. That's what you need to understand. Am I clear? That's what you need to understand. So bacterial and fungal enzymes, they degrade detritus into simple inorganic substances. So this is the complete process is catabolism. So in general, catabolism means breakdown. What is the meaning of catabolism, beta? Catabolism means breakdown. Yes, please. What is the meaning of catabolism, everybody? What is the meaning of catabolism? Yup, people. What is the meaning of catabolism? So catabolism means breakdown. Catabolism means breakdown. So that's what you need to remember here. That's what you need to keep in your mind here. So basically these bacteria and fungal enzymes, they will degrade this detritus. They will break it into simple organic substances. This is what catabolism is. Okay. So all these steps, beta, they will operate simultaneously. It's not going to happen one step, then second, then third. Simultaneously, all these steps are going on. So here, this is what you need to keep in your mind, that humification and mineralization, it occurs during decomposition in the soil. So what is this humification? It leads to the formation of accumulation of dark colored amorphous substance called humus. So what will be there in the humification, beta? What will be there in the humification? So in humification, bache, the dark colored amorphous substance called humus, right? It will accumulate. That is, this humus is highly resistant to the microbial action. It undergoes decomposition at extremely slow rates. Another important MCQ which you need to know, which you need to remember. Am I clear? Am I clear? So humification mein dark colored amorphous substance, they are going to accumulate, which are highly resistant to the microbial action, and they are decomposing at a very slow rate. That's what you need to know, beta. Next point that you have to remember is ki being colloidal in nature, because they are colloidal in nature, so this is also a reservoir of nutrients. This humus is basically the reservoir of nutrients. So humus is further degraded by some microbe and the release of inorganic nutrients by the process known as mineralization. Is that clear? By the process known as mineralization. Is that clear? Is that clear? So humus will be degraded by some microbes, and there is the release of inorganic nutrients, right? Inorganic nutrients, and this is what mineralization is. This is what mineralization is. Understood? This is what mineralization is. Is that clear? Is that clear? Is that clear? So a tree grows in the soil. A green leaf falls to the ground. Some are eaten by insect and other animals. Nutrients and energy will enter the food web. What is happening? There is a tree growing in the soil. A green leaf falls to the ground there. So some are eaten by insect and other animals. Nutrients and energy enter food web. So what will happen? The insects and animals will feed on that, and nutrients and energy, they will enter the food web. So now here what is happening, bache? Some nutrients, they leach into the soil by chemical action, and soil will be, see this organic rich soil, further decomposition by bacteria and bird is happening. And here what are they showing? Look at this leaf, right? There they are showing that some nutrients will leach again. How? Because these are partially consumed by decomposers, that is fungi and bacteria. They begin to lose form and become litter. So yes, sometimes the diagrams you need to, or you should keep it in your mind. Okay, chali, next part. What do we have here? So decomposition, beta, it is largely an oxygen requiring process. So its rate is controlled by chemical composition of the detritus. If it is having more lignin, suberin, so what is going to happen? If it is having more lignin, more suberin, what is going to happen? Its decomposition will be slow. Its decomposition is going to be slow. So the rate of decomposition is controlled by chemical composition of detritus and climatic factors. Just say, let's suppose in winters, right, when the temperature is quite low, you can put your stuff outside. You don't need it to refrigerate, right? Low temperature is there. So in the low temperature, decomposition is at a slower rate. That's why we store the things at low temperature, in the minus basically. So at higher temperature, the increase in temperature, it supports the decomposition. Decomposition will be at a faster rate. So some things you have to relate with your day-to-day life. Then there will be no confusion at all. Right, there are some things which you should relate with your day-to-day life. Is that clear? So the rate of decomposition is controlled by chemical composition of detritus, climatic factors. So in a particular climatic condition, decomposition rate is slow if detritus is rich in lignin and chitin. And if in the detritus rich in nitrogen and water soluble substances, if sugars are there, right, so decomposition is at a faster rate. So next point that we need to understand is ki temperature and soil. Right, temperature and soil moisture, they are other important climatic factors that regulate decomposition through their activities on soil microbes. So what is there? Temperature and the soil moisture. These are other important climatic factors, right, beta? So warm and moist environment, right, favor decomposition. Low temperature and anaerobiasis. Matlab temperature is low, oxygen is not available, then the decomposition is going to be slow. This is important. So if I have to conclude or summarize it, first of all, in decomposition, decomposers will convert organic substances into the inorganic one, right? So the detritus, which is the dead organic matter, which is the raw material for decomposition, we have to break it into smaller fragments, right, beta? And we know that what's going to happen, it will be converted into the inorganic forms. So when it is the leaching, right, the water soluble inorganic things, they will pass to the deeper layers of the soil. They'll be precipitated and will be available as the unavailable, and then will become unavailable salts. Take in humification, basically amorphous substance, humus will form, which is a reservoir of nutrients, which is showing the decomposition, which is basically at a very slower rate it is decomposing. And moreover, we have learned that in detritus, it's its chemical composition, its nature, its chemical composition, its nature will decide, right, the decomposition will be faster or slower. Just chitin, rich things, they take time for the decomposition. If something is having more sugar, it will decompose at a faster rate. This is what we have learned. Moreover, right, the temperature, high temperature, oxygen is very important for decomposition. High temperature, oxygen rich conditions, they will speed up the decomposition, and the temperature is low. So obviously decomposition will be at a slower rate. So this is what we have learned. Next is the energy flow. So here there are some pyramids which we have to remember, beta, and once we are done with it, the chapter will be over. Take it, the chapter will be over. So in next 20 minutes, we will finish this and we will move to the biodiversity conservation. So this is a very important point. Except for deep sea hydrothermal vents, except for deep sea hydrothermal vents, except for what, beta? So except for deep sea hydrothermal vents, one second. So except for deep sea hydrothermal vents, because here the sunlight is not there, otherwise sun is the only source of energy for all the ecosystems on earth, right? So sun will be the only, in the deep sea hydrothermal vents it is not there, otherwise it is the sun which is going to be what? The source of energy. Now beta, out of 100% radiation, if you will think that plants are going to use all, no, 50% will be absorbed, 50% will be reflected back. Out of that 50%, incident radiation, 2 to 10% will be used by the plant for the photosynthesis. So you can see, of the incident solar radiation, of the incident solar radiation, less than 50% of it is photosynthetically active radiation. Matlab, if you think that all of it will get absorbed, no, it will be reflected back, and out of that, the one which is available, 2 to 10% will be used by the plant from that photosynthetically active radiation. So out of the incident solar radiation, less than 50% is PAR, photosynthetically active radiation. In the chapter, in the unit of plant physiology, which we have discussed in detail, beta, there also we have discussed that, right? In that plant physiology unit, we have discussed about it, right? That you know that Vibgyor, right, in that particular wavelength range, this is the wavelength range that will be available to the plants for photosynthesis. So that's what you need to remember here. So of the incident solar radiation, less than 50% of it is photosynthetically active radiation. So plants and photosynthetic bacteria, that is your autotrophs, they fix sun's radiant energy to make food, right? So plant, they capture only 2 to 10% of the power, and this small amount will sustain the entire living world. Imagine. So 2 to 10% of the photosynthetically active radiation is captured by plant. 2 to 10% of the photosynthetically active radiation are captured by plant, right? And this is basically sustaining the entire world. So solar energy is captured by plants. It will then flow through different organisms. So you know that we all are dependent on producers directly or indirectly. And when it comes to the energy flow, there is the unidirectional flow. And what are they saying? Right? Is this in keeping with the first law of thermodynamics? Yes, beta. So is this in accordance with the first law of thermodynamics? Tell me. Yes. So what that first law of thermodynamics says? What is as per that first law of thermodynamics? Everybody. What do you see or study there? Hanji. Beta, first law of thermodynamics is the law of energy conservation. I hope you remember. What is that first law of thermodynamics? It is the law of energy conservation as well. That energy can neither be created nor be destroyed, but can be converted from one form to another. Is that clear? Is that clear? Yes or no? So this is the first law of thermodynamics, that energy can neither be created nor be destroyed. It will be converted from one form to another. So just now I told you, when you talk about the producers, when you talk about the plants, they are going to do what? They will trap the solar energy. What will they do? They will trap the solar energy and they will convert that into chemical energy. They'll trap the solar energy, and what will they do? They will convert that chemical energy. They will convert it into the chemical energy. So what are they? They are the transducers. They will convert one form of energy into another. And even from one trophic level, energy will pass to the next trophic level. Right, beta? From one trophic level, Sadhya, the energy will pass to the next trophic level. Yes or no? So when it will pass to the next trophic level, again it will not be destroyed. It will be converted from one form to one form of energy into another. So this is what you people see. Then they are saying further, ecosystems are not exempted from the second law of thermodynamics, right? So the second law of thermodynamics will also be there. So what is that second law of thermodynamics, beta? That during every energy transfer, some energy will lose as heat, right? Remember, during energy transfer, some form of energy will lose. So during energy transfer, what is happening? Some form of energy is lost as heat. Is that clear? Lost as heat, increasing what, beta? What will that do? That will increase the entropy. So what is the meaning of entropy here? Entropy here means disorder. Anybody in the class who can explain it to me? I'll see how well your chemistry is. Yes, beta? Explain this. Just say we are saying entropy means disorder. Entropy means disorder. Even the ecosystem is not exempted from the second law of thermodynamics, which is simply saying that energy will transfer from one trophic level to another, and during that energy transfer, some form of energy will be lost as heat. It will be lost as heat. So that will increase the entropy, which is basically the disorder, right? So entropy is basically the disorder. It tells us, beta, how disorganized or how disorganization is in a system. Done, beta? Right? Just say, for an example, you are having a hot cup of tea, right? Initially, it is hot. It is that condensed part. It is having that heat. With the time, it will cool. So it's not like energy is destroyed. It is there in the surrounding. You cannot use that then, right? You cannot use that then. So this increase, right, is this increase in the spreading out of energy is an increase in entropy. Is that clear? Done? Yes, bacha? Sure? Okay, so now let me elaborate that. Just simply, see, in nature also, right? Organisms, when you look at the organisms, they feel organized. Ki, hanji, there is a form of energy, that is how they eat, this and that. But still, in the ecosystem, second law of thermodynamics is there. What is happening, beta? Energy will transfer from one trophic level to another, but complete energy will never ever transfer. The energy, some amount of it, 10% of it will transfer to the next trophic level, other will be dispersed as heat. So the one which is dispersed at heat, you are not going to use that. We are not saying it is destroyed, right? But it is not, it is harder to use, but it will be lost as heat. And when you talk about this thing, right, so this is basically what? It is taking the universe towards, it is also taking the universe towards what? Disorderliness, right? More will be the entropy, means more is the disorderliness. So universe also shows that, but just to maintain that, that is why there is a constant source of energy in that ecosystem. Always sun is passing the energy, the source of energy will always be there, just so that it should be maintained. So organisms, no doubt, they look, right, they look organized, but in their case also, the energies when transferred from one trophic level to another, the some form of energy will be lost as heat, and that loss is basically what? That loss we will see here, beta. So some form of energy will always lost as heat, beta. It is not 100% efficient. It will be dispersed as heat, which is less useful for doing work. Is that clear? Is that clear? Okay. Done? So always remember, energy naturally tends to spread out unless work is done to keep it concentrated, right? So that is what you need to remember. Just say clean room means less entropy, less disorderliness, right? So if a room is not cleaned, right? So in that case, the entropy is going to be high. Okay, so this is what you have to remember, that when it comes to the energy, energy naturally tends to spread out unless work is done to keep it concentrated. Okay, so that is why in the ecosystem there is a constant source of energy, right? Because disorderliness is there in that case also, just to maintain that thing ki bhai, it should not be too much, constant source of energy is there. So that is why ecosystem is not exempted from second law of thermodynamics. So they need a constant supply of energy to synthesize molecule they require to counteract the universal tendency towards increasing disorderliness. So yes, even universe will also have this tendency, disorderliness will be there, like entropy will be higher. Just to counteract that, constant source of energy is required, because energy is lost, it is less available to do the work, it will be dispersed as heat. So there is another source of energy, so that synthesis is also going on, further it is passing to the next trophic level as well. Okay, so green plant in the ecosystem are the producers. Terrestrial ecosystem mein beta you have herbaceous and woody plants. In the aquatic ecosystem, you know that you have algae, you have phytoplanktons, like your diatoms, chief producers of oceans. So this is what we have. Now let's talk about the food chain and webs that you see in the nature. So starting from the plant beta, food chains or food webs are formed. You know that in nature it is not the food chain, it is the food web. Always remember, in nature it is not the food chain, it is the food web. So this is what you have to see. An animal feeds on plant or on another animal and in turn is food for another. So the chain or the web is formed because of this interdependency. So if the question is why they are formed, food chains or food webs, interdependency. One species cannot exist by itself. It needs the other species, right? Even plants, those who are autotrophs, they also need the microbes. They also need the animals for their activity. So no energy that is trapped into organisms remain in it for ever beta. The energy trapped by the producers will pass on to the consumer or to the organism, then it will die. Death of organism is the beginning of detritus food chain. So here you people can see all animals, they depend on plants, be it direct or indirect, right? So they are the consumers and the heterotrophs. So if they feed on producers, you know that they are primary consumer, which is basically the herbivores. So this part beta we already know, जैसे grass is producer, goat is basically primary consumer or herbivore, man is going to be the secondary consumer or primary carnivore. If a man is feeding on goat, man is the primary carnivore or secondary consumer. So detritus, now these two food chains are given. One is DFC, another is GFC. So this is what you need to understand next. So when it comes to the detritus food chain beta, so it begins with, so these are the bullet points bache. It begins with detritus, that is dead organic matter. It is beginning with, and it is basically small. It begins with dead organic matter, right? So here, what are they? Here you will see decomposers. You are not going to start with the producers. You will be talking about the decomposers, right? So decomposers will be there, and here obviously you are not talking about autotrophic organisms, rather heterotrophic organisms. So what are they? They are giving you the example of fungi as well as of bacteria. Which examples do you have here? Fungi as well as bacteria. So they meet their energy and requirements by degrading dead organic matter or detritus. So they are also the saprotrophs. So saprotrophs means to decompose. Saprotrophs means to decompose. Is that clear? So decomposers beta, they are the one that will feed on dead or decaying organic matter. So this food chain is comparatively small. So these decomposers, they are going to release the enzymes that will break dead and waste material into simple inorganic one. Is that clear? Then comes the aquatic ecosystem. Here, grazing food chain is the major conduit of the energy flow and important statement. It means channel. What does it mean, beta? It means channel. So in an aquatic ecosystem, it is the GFC, which is the major channel of the energy flow. So as against this, in terrestrial ecosystem, larger fraction of energy comes from the detritus. Beta, this is the most important point. Do highlight this. First of all, detritus food chain starts from decomposer. It is basically short. From decomposers, which are heterotrophs, it will start. Grazing food chain, right? Here, obviously, in GFC, you will talk about the producers first. So GFC is the major conduit for the channel for energy flow in aquatic ecosystem. A very important point. Right, it's a very important point that it is the major channel for the energy flow in an aquatic ecosystem. Major channel for the, and DFC, that is detritus food chain. So in terrestrial system या ecosystem, right, larger fraction of energy flows through, larger fraction of energy flows through DFC. Am I clear? Through DFC. So detritus food chain, right, DFC may be connected with GFC at some levels. So some of the organisms, you know that they are both, right? Just say you can see cockroaches, crow, etc. They are omnivores. They can feed on the plant material as well as on the animal also, omnivores. So these natural interconnections of food chain is making it food web. So that is what we are saying. You cannot say that GFC or DFC is not connected. They will be by some organisms. Okay, chale, next part. So organisms beta, they occupy a place in the natural surrounding or in a community as per their feeding relationship with other. Just if I'm calling somebody as herbivore, why am I keeping it at second trophic level? Because it is a herbivore, it will feed on the plant material. So organism, so here you will not go that at this trophic level, this species will be there. It is about the organism. You cannot say that species, it cannot be something which is species specific. So based on the source of nutrition or food, organism occupy a specific level in the food chain, that is their trophic level. So in trophic level is basically what? So trophic level is as per their source of food, right beta? As per their feeding relationship. Jaise producers will always belong to the first trophic level, herbivores will be to the second trophic level because they will feed on the plant. So this is the example that they have given us, right beta? So that's what you know. You know that some plants, some organisms, they are omnivores. They can feed on plant as well as on animal. So it depends at what trophic level you will keep them. It depends on their feeding relationship. Understood? So diagram based things are important. You know it very well. So next point is saying what? Next point is simple beta. So energy, amount of energy decreases at successive trophic level. Maximum energy will be at producer level, then 10% of it will pass to the next, 10% of that will pass to the next. So with each next level, energy will decrease. With each next level, energy will decrease. So when an organism will die beta, it will be converted to detritus or dead biomass. That will be also energy source for decomposer. Decomposer will bring it back to the circulation. So organism at each trophic level depend on the lower trophic level beta. So each trophic level is having a certain mass of living material at that time. That is the standing crop. So next important topic which you need to know is standing crop and standing state. So we will highlight it from the NCERT, but I'll give you a trick here which work for me. You see if it works for you as well. So we have standing crop and standing state. For standing state, I remember cis. For standing state, I remember cis. Cis, commonly used term. So standing, S is for cis. So I is for what? Inorganic. I is for what? Inorganic. So when you are talking about the standing state, you are talking about the inorganic things in that. When you are talking about the standing crop, you are talking about the organic substance. That's what you have to remember, right beta? That's what you have to remember, right beta? So cis, if you will remember cis, that standing state means inorganic. Automatically it is clear now that standing crop will be the organic matter. So that is what you need to remember, students. That is what you need to remember. So each trophic level has certain mass of living material at a particular time. Each trophic level is having a certain mass of living material. So here you are talking about organic substance. You are talking about biomass here, beta. So this is basically the standing crop. Am I clear? Am I clear? So standing crop is what? So standing crop is the mass of living organism. It is the mass of living organism or the biomass or number in a unit area. So in standing crop, what are you talking? In standing crop, beta, you are talking about the mass of living organism, right? Or the number in a unit area. So mass of species is expressed in terms of fresh or dry weight beta, but when it comes to the measurement of biomass, you will go for the dry weight. Why? Because wet weight, it shows seasonal fluctuation. In case of wet weight, right, seasonal fluctuations will be there. Matlab here water fluctuations, water component in different seasons it varies. So that is why beta we go for the dry weight because it will be more accurate. Okay, so now next is number of trophic level in the grazing food chain. You know that, right? 10% of energy will pass. Okay, so in nature it is possible, it is possible to have so many levels like producer, herbivore, carnivore, secondary carnivore in grazing food chain. So there is So do you think there is such limitation in detritus? Detritus में source of energy is basically your decomposer, right? Right. It is not the autotrophs, it is the heterotrophs. Then it will pass the energy, right? So even detritus food chains, they are comparatively smaller. So you can see beta, you can have a look. So see, first trophic level, but energy will also be dispersed. Second trophic level, it is also dispersed as heat. So you can see that second law of thermodynamics will be there, right? So nature is, the universe is having the tendency to go towards disorderliness. So just to counteract that, we have the source of energy, always sun. Sun is always available, okay? Okay, next beta, there are energy pyramids which we need to know. So base of pyramid is broad, it narrows towards the apex. So here, what you have to remember, I'll tell you. These are the two things that you have to remember. Rest everything will be simple. Number one, pyramid of number for tree dominating ecosystem. These are the 2 points beta that you have to remember. Pyramid of number for tree dominating ecosystem. Pyramid of number for tree dominating ecosystem is inverted slash spindle shaped. Inverted slash spindle shaped, number one. Number two, pyramid of biomass for aquatic ecosystem. Pyramid of biomass for aquatic ecosystem. For aquatic ecosystem is also inverted. Rest all the pyramids, you will study them as the upright. They are inverted only. So if you remember which one are inverted beta, right? So you know rest all will be upright. So even if you keep it in your mind that this one is going to be inverted, so you will be clear that rest all are going to be upright. So that's the point which we need to keep in our mind. So here I will directly explain it from the diagrams. First of all, look at this part, right? So this is the pyramid of number in grassland ecosystem. So what does it mean? Pyramid of number, you are counting the number, more producer comparatively, less primary consumer. See that top consumers, they are lesser. So pyramid of number. So it is also upright. It is also upright. Now, pyramid of number for the grass now, I told you for the aquatic ecosystem also it is going to be what? It is going to be upright. But when you are talking about the same thing in the case of parasitic food chain or tree dominating ecosystem, just see, pyramid of number, right? You are talking about the number one, parasitic food chain. So for parasitic food chain, beta, it is inverted. It is inverted when it is the parasitic food chain. How come inverted? First of all, you people can see, just let's suppose there is one oak tree. Even in a short video, I have also posted the same oak tree. One in number. Then who's going to feed on that? Birds. They are the herbivores. Their number will be more than one. Next will be what? Lice and bugs, which are the parasites on birds. Birds, their number will be larger than this. And then top, right, hyperparasites will be your bacteria, will be your fungi. So got it? So one, there'll be more. So that is why you are calling it as inverted. That is why you are calling it as inverted. Is that clear? Is that clear? Done. So now, if I'm talking about number two, tree dominating. Number two, tree dominating ecosystem. What is that? Tree dominating ecosystem. So here you will see it as spindle shaped. Here you will see it as spindle shaped. Is that clear? Is that clear? So spindle shape means something like this. So you have producer. Here obviously you will talk about herbivore. You will talk about carnivore. And you will talk about top carnivore. So tree, let's suppose producer one in number. So there can be birds, right, etc., etc. They'll be manning the carnivores that will feed on that. Their number will be less. Top carnivores, they'll be few only. Now next is pyramid of biomass. So biomass means you are talking about the organic matter here, beta. Organic matter here. So how do you measure the organic matter? So it is the dry weight that you consider. Why? Because wet weight shows the seasonal fluctuation. So to get the accurate value, we go for this. So in the case of beta, in the case of terrestrial ecosystem, biomass of producers is more. It's in primary consumer it is lesser. But in the case of your aquatic ecosystem, there will be inverted biomass of inverted pyramid of biomass, because these phytoplanktons, beta, P means producer, PC means primary consumer. Phytoplanktons, their biomass is less, their standing crop is less, beta, and that supports the largest standing crop of the zooplankton. So this is the another example. And pyramid of energy is always upright, sorry for this, always upright, because it is only the 10% of energy which will pass to the next trophic level, right? So pyramid of energy, bache, it is always upright, right? So it is only the 10% of energy which will pass to the next trophic level. Baki beta, any calculation of energy content, biomass or number has to include organisms at all trophic level. So these ecological pyramids, right, they are also referred to as Eltonian pyramid, right? Charles Alton has discovered it. So they are also known as Eltonian pyramid, bache. So here obviously there are drawbacks as well. So firstly, let's see. They are saying no generalization we make will be true if we take only a few individuals at any trophic level into account. So first of all, they are saying that any calculation of energy content या biomass or number has to include all the organisms. मतलब we have to consider all the organisms of the trophic level. We cannot make any generalization. Yeah, they will not be true if you will take only few individuals, if you will take only few individuals at any trophic level, right? Also, a given organism, you know that it can be at more than one trophic level. Some organisms, they are omnivores. Maybe it will feed on plant or on insect. We don't know that. It can be at two trophic levels simultaneously, right? And here, one thing that we need to understand, that a trophic level represents a functional level, not a species as such. I told you, right? On the basis of their feeding relationship, we keep organisms at different trophic level. So trophic level is not representing a species, right? So trophic level represents a functional level, not a species as such. A species can occupy more than one trophic level in the same ecosystem, and that too at the same time. Just say a sparrow is a primary consumer when that sparrow is eating the seeds. But you cannot say that the sparrow will eat seeds only, but it can also feed on insects. So that is why I am saying that in a food chain, it can simultaneously be at different trophic levels, right? So in most ecosystems, all the pyramids of energy and biomass are upright. Jैसे producers are more in number, biomass and all. And here they have also given कि for energy, so it is always going to be upright. So exceptions are there, beta. We have already covered that. Baki. So if you will count the number of insects feeding on a big tree, what kind of pyramid you will get. So this is what they are explaining that we have already covered. So pyramid of biomass in C is inverted, right? This is also done. For energy, it is always going to be upright. So next is, however, there are certain limitations of these pyramids, right? Limitations are also there, beta. What they don't consider. First of all, in these pyramids, you are not talking about this thing. It doesn't take into account that same species belonging to two or more trophic level, right? That same species belonging to two or more trophic level, it assumes a simple food chain, right? And in nature, it is always the food web, beta. In the nature, interdependency is there, so there will be the food web. Moreover, saprophytes, decomposers, beta, they are not placed in ecological pyramid, and you know they are the most important one. So the next part is this. So this is all about the ecosystem as well, that within an hour we have finished, beta. So next will be your biodiversity. Done, beta. Next is your biodiversity. Okay. Next is your biodiversity. Within 2 hours we will finish it. So by 6 you all will be free. Okay. Okay. So ecology will give you direct MCQs. Right, solve last 10 years PYQs. And today at 9 p.m. also I have another session where genetics and biotechnology MCQ practice will be there. So make sure you install the pylons. Okay. Chaliye, next. So answer these questions. Again, you can see in 2026 also they have asked the question. So you know ecology is important, right? Eco is very important here. So I'm starting the poll. Answer this to me. Quick. Quick. Done, bacha? So, ecological pyramid represent the relationship between organisms at different trophic level, and they are generally inverted for pyramid of biomass in C. Isn't it? In C. Next question. This is a statement based question. This is a statement based question. 2025 PYQ it is. So I'm starting the poll here. Quick, go for it. So the primary source of energy in an ecosystem is solar energy. Hanji. The rate of production of organic matter during photosynthesis is not the NPP, it will be GPP. So first is correct and second is incorrect, isn't it? Next question. Which of the following is unit of productivity in an ecosystem? Again 2025 PYQ bache. So which of the following is the unit of productivity of an ecosystem? Which of the following is the unit of productivity in an ecosystem? Unit of productivity in an ecosystem. Hanji, unit of productivity. So beta, out of all we know that it will be kilocalorie per meter square per year, isn't it? So I'm going to stop the poll. So it's very easy. So I hope you are clear with it. Chaliye, next question. In ecosystem, next question. Again 2025 PYQ. I've started the poll. Read it and answer it, everybody, quick. Again, it is very easy, beta. So in ecosystem, there is a unidirectional flow. True that. Ecosystems are exempted from second law. No, they are not. So one is true and second is false. One is true and the second is false. So statement one is correct, but second is incorrect. So again, the answer is going to be C. Both are correct. Are you kidding me, beta? Ecosystems are not exempted from second law of thermodynamics. Just now we have discussed that. Chaliye, next question. Next question. It is a good question. It is a good question. In 2024, many teachers, they came up with this thing. This is a controversial question. You will get the bonus for it, but actually it is not. I'll simplify it. In an ecosystem, if the NPP, right? If the NPP of first trophic level is 100x, okay, kilocalorie per meter square per year, what would be the GPP of the third trophic level. So on what basis teachers were saying that it is a controversial question? They are asking the GPP of third trophic level. So they have given you NPP of first trophic level, that is going to be 100x. Okay, ji? So this NPP will work like what? So you know that 10%, it is the 10% of that will pass to the that will pass to the next trophic level. So 10% of that will be, that is 10x. It is the 10x which will be available to the next trophic level. Right. Firstly, they are saying what? NPP of first trophic level. NPP of first trophic level, I told you this is the secondary productivity of the next trophic level. And it is only the 10% that will pass to the next trophic level. So if it is 10x, and from the 10x, it will be the x that will pass to the next trophic level. This is what we need to know. Now, teachers, they were saying it is a controversial question on what basis ki GPP is written. Primary productivity is at the first trophic level only. How can they ask the primary productivity at the third trophic level? So no doubt beta, sometimes we have to understand the context of the question, right? Because from NTS side, these are the kind of things that you are going to see every now and then. If you will think that one day they'll give you question paper with no error, not possible. So as per that, you have to go for it, and as per that, we have to figure out the answer. Is that clear? Is that clear? So no way it is going to be your right. So it was not at all the controversial question. So this is how we have to understand a particular topic. Is that clear? Is that clear, beta? So that's what you need to know. So if there is any doubt in this question, then do let me know. So 10% factor will be applicable here. Okay. So whatever is the NPP of first trophic level, that will be available as the gross secondary productivity of next trophic level. Right. So only 10% of that will be passed to the next trophic level. Okay. So X is going to be the answer. So 10% of it will pass to the next trophic level. That will be 10x. Then third will have X. Right. So it is not strictly GPP, right? Because GPP will be done by the primary producers only. So you should know the concept, and accordingly you have to figure out the answer. So next is our last chapter, beta, biodiversity. Right. Here also what you have to take care. Dekho, there are some questions from, see, firstly, this thing, biodiversity conservation, very important topic. First important topic is biodiversity conservation, and even whatever they have, whatever conservation in situ, ex situ, after that, whatever they have mentioned, this conference happened here, this conference happened there, that is also something you have to remember. That's an important question. Second is the causes of biodiversity loss. Causes of biodiversity loss. Third important question. Fourth is the patterns of distribution of biodiversity, pattern of distribution of biodiversity, or to be more precise, species area relationship. So these are the topics which you are not allowed to miss from this particular part, right? These are the topics which you are not allowed to miss from this particular chapter. So that's what you have to keep in your mind. So this is a species area relationship and biodiversity and conservation. Is that clear? Is that clear? Done, bache? So any other doubt? Pakka? So let's start the third chapter. Let's try to finish it by 6 or 6:30 so that you will be free. And then when are we going to meet? We will meet at 9 p.m. today. For what? For genetics and biotechnology MCQ. So you know that genetics and biotechnology, both are the most important units, right? Both are the most important units. So we are going to finish them all together. Okay, so this is what I'm checking. Let me see whether the class is live or not. I think it's live, hai na? And guys, what you are doing, if you are new to our channel, why can't you subscribe it? And why can't you hit the like button? Right? Do hit the like button. Chaliye, let's go. So, now this chapter, here you don't have to highlight anything. In an alien, if alien will see our planet, that alien will be baffled. Wow, biodiversity is there. So what we have to learn here, biodiversity. Who popularized the term? Edward Wilson. So there are some scientists which you need to remember from this chapter. So I'll write them here. Edward Wilson. You will talk about the Alexander von Humboldt, David Tillman, Paul Ehrlich, one more is there, Robert May. So at least remember what have they done. Direct question. Okay? Now, from this particular paragraph, what we need to understand. This number we have to remember that there are more than 20,000. No doubt this data is not up to the mark, right? It is not the latest one, but still. So 20,000, more than 20,000 species of ants, 3 lakh species of beetles, 28,000 of fishes, and nearly 20,000 species of orchids are there. So this is what we have to highlight from this particular paragraph, right? So as per the important topics or as per the important statements, I'll move ahead. So this is something that you have to remember. So what is it? What is it? First of all, we are saying more than 20,000 species of ants, 3 lakhs of beetles, 28,000 species of fishes, and nearly 20,000 of orchids, right? So ecologists and evolutionary biologists, beta, they are trying to understand what is the importance of diversity, why is it important. So we will see that. So here what they have given, ki in our biosphere, immense biodiversity or heterogeneity is there. It is not homogeneity. Heterogeneity is there, beta. It exists only at the species level, not only at the species level, but at all levels of biological organization, ranging from macromolecules to biomes. So, matlab diversity is there at all the possible levels. This is what they are saying. So, as I told you, this is the another important thing, that biodiversity is the term popularized by social biologist, right, Edward Wilson. So, who popularized this term? Who popularized this term? Right, sociobiologist Edward Wilson, and he described the combined diversity at all levels of biological organization. So the very first one is genetic diversity. Very first one is beta genetic diversity. So diversity at the level of genes, at the level of, right? So single species, जैसे we all are individuals of single species. So we are also diverse. Why? Because our alleles are different. है ना, mutations are there, our alleles are different. So we are also not ditto like each other, right? So we have undergone the mutations. So this is something you need to keep in your mind. So single species might show high diversity at the genetic level, right, over its distributional range. So from this particular topic, what do they ask in the paper? They ask the question. So here the example is of Rauwolfia vomitoria. Rauwolfia vomitoria is the example, beta. So this is a medicinal plant from which you will get an alkaloid, that is reserpine. This is the alkaloid that is obtained from that. It is used to treat high blood pressure, that is hypertension, beta. Yes, this is used to treat hypertension and mental disorders as well. In the mental disorders also, this drug, this alkaloid is used, right, beta? So it is Rauwolfia vomitoria, that is disorder. So that is what you need to remember. So it is giving us, so in the NCERT, whatsoever examples are given, that is what you have to understand. And overall, you can see that at our level also, right? We are the individuals of same species, but we have the differences, because we have the differences at the genetic level, at the gene level. Our alleles are different, right? And why is it different? It is because of the mutation. So you can see here very clearly, a single species might show high diversity over their distributional range, right, beta? Just say you have the example of what? You have the example of Rauwolfia vomitoria, bache. So it is basically found in different Himalayan ranges, right? So here the potency and concentration of the active chemical reserpine is different. Just say, let's suppose you can see that, just say a pashmina shawl, it is right, for pashmina shawl, the wool, right, which we have to take from the sheep, if I'm not wrong. So that sheep, they should be at a very higher altitude, something like that. I'm not sure of it, just giving you examples. So basically what is going to happen when you talk about the Rauwolfia vomitoria, let's suppose one is in the plain region, one is at the height. So the potency, the ability of that chemical, right, plus its concentration, it varies. So this is what you need to remember here. The potency and the concentration of active chemical reserpine that the plant produces, it is different, right? It is different. Just say potency as in, sometimes for some solutions, even the 2 drops are there sufficient enough, and sometimes you have to put 10 drops. That's how you talk about the potency, their ability. Just say 2 drops are sufficient enough means it is more potent. Another one is less potent. It is like that, Okay, so here you can see Revolvia vomitoria, which is growing in different Himalayan ranges. This is the first example. What are you getting? Rhizopine. And when it comes to the rhizopine beta, it is an alkaloid which is used to treat the high blood pressure as well as the mental disorders, right? Now, next example is of rice. Basically, India has more than 50,000 genetically different strains of rice and 1,000 varieties of mango. So, database questions can come, which I am highlighting here. Next is the species diversity. So, beta, when we talk about the species diversity, right, when we talk about the species diversity, so here there are two factors that you have to understand. One is the species richness and another is the species abundance or the evenness, right? So species richness is there, another is species evenness, bache, which is also known as species equatability, which is also known as species equatability. So that's what you need to remember. So species richness. So here you are talking about number of species, okay, number of species. And here what are you talking? Number of individuals of species, or I would say abundance of species. So how do we understand that? And when it comes to the species diversity, you consider both the factors, right? So let's suppose there is a plot. In that plot there are let's suppose this is area A, 1, 2, 3 or 4. It is having 4 different type of species. Look at their abundance. You can see this is species number 1, 2, 3 or 4. It is the 4th species which is dominating there. Its abundance is more. Number of individual of the species is more. 3 very less. 2 very less. It is like that. Now let's suppose there is another area. Let's suppose there is another area. Look at this. So it is showing 4 different species and here their number is almost, right, almost equal. I'm not saying equal, almost equal. So here species richness and abundance both are there. Here a particular species is more, right, others are less. So that's how you can just compare it or you can understand that. So what do we have here, beta? Species diversity. So you have species richness or species evenness or species equatability. So both the factors we have to consider here. So diversity at the species level is basically the species diversity. So Western Ghats have greater amphibian species than the Eastern Ghats. So along with that species richness and evenness, this is the third point that you have to understand. Then ecological diversity. But when I explain it in detail, I also talk about ecological diversity, a community diversity, or this is the ecosystem diversity. So we discuss it like this: alpha diversity, beta or gamma. In alpha, you talk about the diversity within communities, right? Beta mein you talk about between different communities. Obviously geographical area will also be different. In gamma diversity you will consider the complete geographical area, right? So here, but we are sticking to the NCERT and that is what you need right now. So at the ecosystem level, they are giving us the example of India. They are saying they have deserts, obviously, because a large part of India is in the tropical range. We have rainforest, mangroves, coral reefs, wetland, estuaries, alpine meadows, right? So we have the greater ecosystem diversity than a Scandinavian country like Norway. So what is this Scandinavian country or what is it? Dekho beta, even in our junior grades also, this is what we see. Let's suppose this is Earth, an imaginary line will pass through it, right? Do you remember? An imaginary line will pass through it, that is equator. So firstly, let me clarify that, so that equator, hai na? So this is going to be your North Pole, this is going to be your South Pole. Hanji, how many of you know that? How many of you know that? So first we will discuss that. Yes, first we will discuss that. Hanji, first we will discuss that. Just we have the equator, we have the pole. So equator is basically at what? An imaginary line which is passing from the middle of the earth, right? Yes or no? Yes or no? So here you know that if we go as per NCERT also, just let's suppose if this is the area that I'm considering. So I call it as the tropical area. So here just say 23.5 degree N, 23.5 degree S. So this is the tropical region. So this is firstly 0 latitude. This is your equator, right? This is what? This is your equator, and imaginary line is passing through the center. So this is your, this complete part here is basically what, bache? This complete part here is what? This complete part here is your, yes beta, tropical region. So here you will see that this part is receiving maximum sunlight, right? This part is receiving maximum sunlight is there, maximum snowfall is there, the temperature is going to be very high, the productivity is also very low. Remember that the productivity is also very low. Then comes the temperate region, and finally comes the pole. So you have the Arctic, right? Here North Pole is basically Arctic and South Pole is Antarctic. So anybody in the class who can explain it? So first you talk about the tropical regions, then you also talk about the subtropical, temperate, subtemperate region, but I'm just writing these two only. So you have tropical regions, temperate regions, and then finally we talk about what? We talk about the poles here. So tropical regions are there, temperate regions are there, then you talk about the poles here. So when it comes to the poles, beta, very cold climate, long winters and short summers will be there. Okay? What will you see? At poles, what you will see? Right, temperature is going to be low, hai na? Temperature is going to be low, the temperature is going to be very low. So we can say here we see long winters, right? Long winters are there, and short summers are there, beta. Short summers are there. So long winters will be there. So Arctic or Antarctic. So North Pole is basically Arctic or Antarctic. So do you know the difference here? Anybody? Do you know the difference here in this Arctic and Antarctic? Yes? Right? So no, it is basically beta mostly the frozen. It is basically what? It is the frozen ocean, Arctic region. Do you know that? So conditions are too extreme here. So it is basically the frozen ocean which is surrounded by land. Okay? Right? Right? And here you will see a landmass covered by ice. Done? Okay, so frozen ocean, and here you will see the landmass which will be covered by ice, right? So climatic conditions, right? No doubt in Arctic it is cold, but in Antarctic, beta, even it is colder than the Arctic. So penguins, seal, whales, you will get here, right? Say penguins, seals, whales, you are going to find in the Antarctic region. The conditions are more colder than Arctic, and polar bears and all, they will be in the Arctic region. Is that clear? So in Arctic region still, right, some people they live, but in Antarctic only research stations are there, bache, right? Only research stations are there. So that is how they are different also. So polar bears, but here still you will see some, you know, indigenous people, they can live, those who are adapted to live in such condition. But here you'll mainly see the research stations, because the conditions are colder than that. So in tropical region, beta, whenever you will see the sunlight is going to be high. So high sunlight, high temperature, more rainfall, more productivity, more plants. If plants are there, you know that this is how the evolution is. Right, plants are there, means which are autotrophs, they can make their food. So obviously animals which will feed on that food will also be there, So if there will be more productivity, more plant, more everything, so obviously you will also see if plants are more, the animals will also be there. So that's what you have to remember. So overall the thing that you have to understand is that India, the major part of India is in the tropical region, right? Right. So Scandinavian country which is in the temperate region. So one fact that you have to understand here only, that when we move from equator to pole, right? When we move from equator to pole, biodiversity decreases. This is the fact that you need to understand. the biodiversity, it decreases. This is the fact that you people need to understand. Is that clear? So that's why the fact is given here ki India will show more biodiversity than a Scandinavian country like Norway. Now, what else are they saying? Ki millions of years of accumulation, that's why this biodiversity is there, right beta? So biodiversity is and its conservation is very important. So whatever I'm highlighting, you go for that. Okay? Now what are they saying? According to this full form is beta very important, International Union for Conservation of Nature and Natural Resources. So it is as per IUCN 2004. When I used to study in class 12th, right, we got the same book. They didn't even update. They didn't even update after that. So International Union of Conservation of Nature and Natural Resources, as per this IUCN 2004, total number of plant and animal species described so far is slightly more than 1.5 billion. So let me clarify this thing here, bache. So when you people study class 11th NCERT for living world, right, in that particular chapter, they have mentioned that the number of species is 1.7 to 1.8 million. 1.7 to 1.8 million species are there. And one more thing I would like to specify, that here you are only talking about the eukaryotes. You are not considering the prokaryotes here. Here you are only talking about the eukaryotes. You are not considering the prokaryotes. That's something you need to keep in your mind, right? So here they are saying that 1.7 million to 1.8 million species are present, and they are just the eukaryotes. So as per class 12th NCERT biodiversity, what are they saying? They are saying more than 1.5 million. So more than 1.5 million, matlab both the data you need to remember. So it means 15 lakh. This is what you are talking. So more than 15 lakh means somewhere in between 17 to 18 lakh. That's how you can keep it in your mind. So class 11 NCERT says this, class 12th NCERT is saying this. So both the data should be clear in your mind. So more than 1.5 million means somewhere in between 17 to 18 million. Oh, sorry, 17 to 18 lakhs, not million. More than 1.5 million means more than 15 lakhs, somewhere in between 17 to 18 lakh. And here you are only talking about the eukaryotes, not the prokaryotes. So as per this 1.5 million species are given, and they are saying there are many species which yet to be discovered and described. So estimates, these estimates are different. Just say for an example, let me elaborate this particular line. For many taxonomic groups, species inventories are more complete and temperate than in the tropical countries. What is the meaning of this line? देखिए बच्चे, so now in the tropical areas, जैसे let's suppose if this is the part, this is your tropical area. In the tropical area, you imagine this thing. Sunlight is there, maximum sunlight, high temperature, more rainfall, more productivity. So plants, animals, they'll be too much. Now when you talk about the temperate region, the seasonal fluctuations are there. Here conditions will be same for many years. That's why speciation is more. Understand this. There is an area where conditions are constant for a longer period of time. They are favoring more productivity. More plants and animals are there. So that will be dense area. That will be a dense area. Now there is a temperate area where seasonal fluctuations are there. Glaciation will be there. So conditions are not constant for a longer period of time. So in that area, less species, new species formation will be there. So I'll give you an example. Let's suppose if I will teach a class with 200 students. If in my class I have 200 students, even, right? Let's suppose not everybody is a topper or something, but still I'll take time, right? I will take time to check their notebooks, to check their paper. Number one. Now there is a class with 50 students. Obviously here I'll do it fast. है ना? Same is the case here. When you are talking about the tropical areas, so in the tropical areas, what you people will see? In the tropical areas, you will see, because there are more number of species, so beta, to study them, to discover them, to enter them in that species inventory where we write everything, right? It is going to take time. But in tropical area, temperate areas where lesser number of species are there, so it will be easy for us to see that species, right, to decode them, or to discover them, describe them, and to mention that in species inventory. So that is what they are trying to explain here, right? That is what they are trying to explain here, that for many taxonomic groups, species inventory are more complete in temperate region. Matlab in temperate region, we know more about the species which are present there in comparison to tropical countries. I have explained you the reason as well. So in tropical countries, beta, right, there are many species which are yet to be discovered. So statistical comparison of temperate or tropical species, richness of an exhaustively studied group of insect, and extrapolate this ratio to other groups. So basically they have given us an idea. They are saying कि as per the estimates, some extreme estimates say that there are 20 to 50 million species, right, that are yet to be discovered. But more scientific that we consider is of Robert May. So this is the second scientist name, right? It's Robert May. So as per Robert May, the global species diversity is about 7 million. 7 million, right? Matlab we have this, we know about more than 1.5 million, but there are 7 million, right? Global species diversity is 7 million. So it is more scientific, which is accepted. Now, next part is कि when we study that, when we compare that, then what we got to know that more than 70% of all the species recorded are animals. Matlab we have more animals. So more than 70% is animal beta. So plants plus fungi. I don't know why they mentioned it together here. Plants plus fungi are making no more than, it is not just the plant beta, they are also considering the fungi, no more than 22%. Matlab 70% you are clearly saying animals. And here in animals also, out of 10, 7 are insects only. Out of 10, 7 are insects. And when you are talking about this, so here they are saying algae, fungi, bryogymnoangio. So plants plus fungi is no more than 22% of the total. So out of the animal, insects are the most species rich taxonomic group, right? So more than 70% of the total. So it means out of every 10 animals on this planet, 7 are insect, right? Or you know that in the insects, exoskeleton is there, chitinous exoskeleton, more degree of protection, this and that. Okay, so now next data that you have to remember is, for this next data, how can you remember? The trick here is going to be fungi farm. The trick here going to be fungi farm. This is the next data that you have to remember. Fungi farm. So what does it mean? F stands for fish, amphibians, reptiles, and mammals. This is the trick. This is the meaning of this trick. Fungi farm. What is the meaning of fungi farm? Then they are saying that the number of fungi species, in the world is more than the combined total of species of fishes, amphibian, reptiles, and mammals. That's why fungi farm. That the total number of species of fungi is more than the number of species of fishes, amphibian, reptiles, and mammals. Is that clear? Now, do we need to remember that? Yes, beta. We should know how to decode that. Just here, if I will see, they are saying insects, right? Here they are saying insects are maximum. After that, other animal groups. As per NCERT, I'm trying to tell you. Other animal groups. Then, next is what, beta? Mollusca. Then is crustaceans. This is what it is saying. Now, fungi farm is there, but in vertebrates, what are they showing? Maximum is fishes. Then they are showing beta birds. Then they are having reptiles. And then you will see amphibians and mammals, because they are almost same. That's what you need to know. Here when you see fungi, then angiosperms, then bache algae, then you have mosses, then you have ferns and allies, and then you have what? Lichen. So try to solve it, try to practice it, try to remember it. So yeah, this is also something that we need to know. Now next part, what are they saying here? Ki whatever number of species we considered, so these estimates do not give any figure for prokaryotes. So you are not talking about the bacteria here, you are not talking about the prokaryotic organisms here. Why not prokaryotic organisms? Because beta, we are not that well equipped ki we can grow them in the lab. And in the case of prokaryotes, bacteria, you know, they are having too much of differences, right? Different strains they have, right? Molecular level pe they have so many differences. So that is why biologists are not sure how many prokaryotic species are there, because the conventional taxonomic methods, they are not suitable for identifying these microbial species. We cannot culture them under lab condition. And if we accept biochemical or molecular criteria, beta, here, so then this diversity alone will go in millions. So here you are not talking about the prokaryotes. Now, next part is, although India has only 2.4% of the world's land area, but now global species diversity it is contributing 8.1%. Matlab area is 2.4%, but diversity 8.1%, number one. Now, India is one of the 12 mega diversity rich countries of the world. Now, I would like to specify here. So, this is as per NCERT. So, as per latest data, you have to remember both. If in paper they have given NCERT as well as latest data, you will go with the latest data. They are not going to do that. Either they will ask you the question on the basis of NCERT or the latest data. So, you should know latest data as well. So, the number is 18. Number is 18. So, nearly as per that, what are they saying? Nearly 40,000. Matlab, if you apply all that things, 40,000 species of plants, twice as many as of animals have been recorded from India. This is what we got from India. Now, on it, if we apply Robert May estimate, because as per him, only 22% have been recorded so far. So if you apply his data on India only, so you will say that there are probably more than 1 lakh plant species and more than 3 lakh animal species are yet to be discovered and described. So Robert May said that about 7 million species are there which are yet to be discovered and described. Now we said that India is having land area is 2.4%, but when it comes to the biodiversity, 8.1%. So from India, around 45,000 and twice many as plant, twice animals as many, twice of that plants we have the animals. So if we apply the Robert May estimate, so we are saying that more than 1 lakh plants will be there from India only, and plant species rather, not plants, plant species, and more than 3 lakh will be of the animal species. So it is not animal, it is animal species here, right? So for that beta, obviously we need more taxonomists, more time is required, but the way we are going, right, the biodiversity loss is there. So here they are saying in nature's biological library is burning even before we catalog the titles of all the books stored there, stocked there. So this is quite like this chapter of NCERT, I really like the language there. So they are saying ki extinction is at such a fast rate, right, that before the discovery of the species, might be they will get extinct. That is what they are trying to say. Next part, patterns of biodiversity loss. Already explained you this part beta. So as you move from equator to poles, biodiversity decreases. You move from pole to equator, biodiversity increases. We go for the latitudes, right, from this equator to north, equator to south wala. We are not going from north, this east to west thing, because here we see that generally, right, just say here if you are moving, generally you will find the conditions are going to be same. So majorly we go for that. One example on the basis of longitudinal that you discuss is eastern or western Ghats. Right, eastern or western Ghats. So you know that the more species will be there in the western Ghats. So here you are measuring what? You are measuring the latitudinal gradient, right? Not the longitudinal one. Rather, what are we seeing here, beta? We are talking about the latitudes here. Am I clear? Am I clear? So you are talking about the species diversity from equator to poles here basically. So longitudes may you will go east and west, right? Latitudes may you will go north and south. Done, beta? Done. So longitudinal gradients are not as strong as latitudinal one. No doubt they are influenced by climate, ocean currents and rainfall patterns and geographical barriers, right? So yes, we have the example of Western Ghats and Eastern Ghats here. Done. Western and Eastern Ghats here. Done. Sure. So diversity of plant and animal is not uniform. So that's what I have already discussed. So this diversity is not uniform throughout the world. So this distribution is uneven, beta. What sort of distribution do we have? Uneven distribution. Is that clear? Is that clear? So species diversity decreases as we move away from the equator towards the poles. So you can see that in the latitudinal range of 23.5 degree N to 23.5 degree L, S, they have more species than temperate or polar areas. So this data is again given here. Just say we have Colombia located near the equator. So if it is located near the equator, it is having more species of birds. New York, beta, 41 degree N, it is not in the tropical region, 105 species. Greenland, right, too close to the poles, it is having only 56 species. And India, because it's much land areas in the tropical latitudes, more than 1200 species of birds are there. So if you compare Ecuador, which is up to 10 times, as it is having 10 times more species than the vascular plants, right, and it is having equal area in the Midwest of USA. Matlab, you pick up a forest from Midwest of USA, you compare it with Ecuador, they are having same area, but number of species will be more in Ecuador because it is in the tropical region. So here this is what they are specifying. Now next part of data is, beta, simple, that here Amazonian rainforest, it is basically the lungs of planet Earth, right? So in South America it is, so it is having more than 40,000 species of plant, 3,000 of fishes, 1,300 of bird, and 427 of amphibian and the mammal. So this data they can ask you, question they can ask you. So 378 of reptiles and more than 1,25,000 of invertebrates. So this is something we need to remember, right? Right. So even they are saying ki here you have more than 2 million insect species which are waiting to be discovered. So why in tropical regions we have such a great biodiversity? So evolutionary biologists, beta, they have proposed various hypotheses. So they are saying speciation. What is the meaning of speciation? So speciation means the process of formation of new species. So beta, for speciation is a function of time. Speciation is what? Speciation is a function of time. So unlike temperate regions, right, where there is unpredictable conditions, there are frequent glaciations, right, beta, they are disturbed, but tropical regions, they are undisturbed for million of years. So because they are undisturbed for million of years, same type of conditions are for a longer period of time. So here you will see that speciation is more. And moreover, in tropical regions, beta, there is niche specialization. Do you know what is niche? Niche means, जैसे habitat is like my address, niche is just like my profession. Niche means functional role of an individual species in an ecosystem, right? The role, their profession, what are they doing? Just let's suppose in aquatic, habitat is aquatic, they are living in water. What are they doing there? Herbivore, carnivore, that can be different. So tropical regions may, right, biodiversity is too much. So here there you will find the species which are having niche specialization. This is our role in this ecosystem, right? So second reason is tropical environments, unlike temperate ones, already told you, they show less seasonal and more constant and predictable conditions. And third thing is more solar energy, more productivity. That is why in tropical regions there will be more species, right? So next is third scientist name, Alexander von Humboldt. Beta, he was not blessed, na, like you people. He was not having Instagram, Telegram, this gram, that gram. So he was the great German naturalist and the geographer, Alexander von Humboldt. So he, right, visited what? He visited the South American jungle, South American forest, right? And what he observed, this is a very important topic, please pay attention, that within a region, species richness increases with increased explored area, but only up to a limit. What does it mean? Just say, let's suppose I am somebody who started exploring a region that is A. In A, I am finding some, 10 species. When I have increased my area to B, then I'm like, oh wow, I got 12 species, or 13 species, 15 species, right? And then after a certain limit, when even I was increasing my area that I am exploring, that richness is not increasing that much. So what as per the species area relationship, right, who basically a great German naturalist and geographer Alexander von Humboldt, right beta, he explored that South American jungles and he observed that within a region, species richness is increasing. In a particular region, yeah, the richness in species, it is increasing. Species richness is more. But right, when I'm so he was like, species richness is increasing when I'm increasing the area to be explored, but it is happening only up to a limit. Just when I'm moving from A to B, okay, richness is there, B to C richness is there, C to D richness is there, but after that I'm not able to see anything like that. So he applied this relationship on wide variety of taxa. Taxa, you know na? Taxa, the technical term that you use for these categories या hierarchy, the categories, the units of classification mein. So angiosperms, plant, birds, bats, they all give the same type of data. They all presented what he got when he studied that it is giving a rectangular hyperbola. So on a logarithm scale beta, when we apply that, it is this relationship is a straight line. So basically, as per Alexander von Humboldt, when we increase the area to be explored, the species richness increases, but only up to a limit. So only up to a limit is the keyword here. So it is basically S is equals to CAZ, right? So S is the beta species richness, A is area, Z is the slope of line, regression coefficient. It tells us about the relation between two variables, and C is basically the y-intercept. And on logarithm scale, it is log S is equals to log C plus Z log A, and this relationship is basic. This on logarithm scale, it's a straight line. Then only you can see the value, na? That's why you go for the straight line. So firstly, tell me, anybody having any doubt here? Anybody having any doubt here? First, you tell me this. First, you tell me this. Yes? Then I'll tell you about the values. Have a look, beta. Even if anybody is having any doubt, just do let me know. Yes, madam, this is the doubt we have. Done? Quick. So S is equals to CAZ. So log S is equals to log C plus Z log A. So Z is the species area relationship. Z is the regression coefficient. Is that clear? Or it is the slope of line? Okay. So Z tells us what beta? So first of all, regression coefficient, that's how you study that. It tells us about the, right? It tells us about the relationship between two variables. Jaise area you are changing, species, diversity, richness you are exploring. So the relationship between two variables is explained by regression coefficient. So when I'm talking about the Z, what exactly is the Z? It tells us how fast species richness increases. It tells us how fast species richness increases. How fast species richness increases with an increase in area explored. In simple words, is it clear? Ki what exactly is the Z? What exactly is the Z? In simple words, is it clear? So it is telling us how fast species richness increases as area increases. Okay? Done? So if there will be low Z value, it means species richness is not increasing, increases as area increases. Done, beta? So this is what, and for the high, you know that species richness will also increase as you increase the area, right? So species increases, richness is not, or I would say slowly increases as the area increases. It is increases slowly. Or for high Z value, bache, so species richness fastly increase with increase in area. This is what you have to remember as per the values. So these are the simple pointers that you need to keep in your mind. Is that clear? Is that clear? Done? Okay. Sure. Sure, बच्चे, do you have any doubt and why is it so? Why is it so? देखो बेटा, when you increase the area, just like continents, the habitats will change. Environmental conditions will also be changing. So different habitats, more diversity. That's why you are having high Z value when you consider a very large area. So regression coefficient done. It tells us how much one variable change when another variable change. So it is telling us about the relationship between two variables. So it tells us how one variable change when there is change in another variable. So now any doubt here, bache? Any doubt here? I hope these terms are clear to you. I have seen students, they just cram this part. They don't even know what is the meaning of line. Right? What is the meaning of this line? Okay. So any other doubt? So what is the meaning of y-intercept? What is the meaning of y-intercept? Beta, y-intercept na in maths we say it is the value of y at which x is 0. Right? In a straight line equation, this is how you study. That what is this y-intercept? It is the value of y when the x is 0. It is the point where, line cuts the y-axis. So if it will cut the y-axis, right, the value of x you will say it will be 0. So y-intercept, this is what you are talking here. So I hope this part is clear. So ecologists, they have discovered, bache, right, ecologists, they have discovered that the value of z lies in the range of 0.1 to 0.2, regardless of the taxonomic group of the region. Right, it can be anything. It can be plants in Britain, birds in California, mollusks in New York. Yes, you need to remember these details also. And the slopes of regression line are amazingly similar. Right? And now they are saying that when you study a very large area, जैसे कि continents, then you will see the slope of the line. Slope of the line will be more steeper. Right? So Z values will be in the range 0.6 to 1.2. So for fruit eating, frugivorous bird, mammals in the tropical forest, you'll see the slope will be this. So this value is important. So what is the meaning of steeper slope? Beta, so obviously you are considering a larger area. You are considering a larger area. So larger area means, so species, the species richness will also increase fastly. Right? Right, beta, because continent hai, different habitats will be there. So this is what you have to consider. So steeper slope means line will rise more quickly. Right? So that's what you have to remember. Okay. So a steeper slope means, you can write it also, it signifies number of species found increases faster than the number of species found increases faster than the area explored. Done, beta? So that's why it is, richness is increasing at a faster rate. So that's what you have to understand. So steeper slope means that the number of species found increasing faster than the area explored. And where will you see that? In the large areas. In large areas like continent. Is that clear? In the large areas like continent, that is it. So this is the meaning of this part of NCERT. So that is why I say, beta, when we decode the NCERT, we also answer these questions. Ki what do you understand with the steeper slope? Steeper slope means number of species found increases faster than the area explored. Matlab that increase is too much here, right? It is. So now importance of biodiversity. Here, beta, we have two analogies as well. So we are about to finish it. Please pay attention. We are about to finish it. Please pay attention. So till this part, do you have any doubt? Done? Hmm. Chaliye, let's go for this. Now, they are saying ki why? Why do we need all the species? Why do we need all the species? What is the meaning of having a stable community? Right? Just say here they are saying ki for many decades, ecologists believe that the communities with more species generally tend to be more stable than those with less species. So communities which are having more species, they are more stable. They are more stable than those with the less species. So what is the meaning of the stable community? Beta, a stable community should not show too much variation in productivity from year to year. Like the biomass, that productivity, it should not be it should not change so frequently. If it is not changing, means the community is stable. Why is it so? If a community will have more biodiversity, just say, let's suppose if there is a field, in that field if you are going to grow one particular type of crop only, if there will be any environmental disturbance, any pest will be there, so it will all be destroyed. Now in the same land area, if you are having different plants, right, so even if let's suppose one will get damaged or something will happen to that, others will be there, right? So biomass will not be at that much, right? The productivity will not be that low. So stability is there because of what? Stability is there because of what? Because of the variation. So here what are they saying? Matlab, it's like a joint family. In the joint family, let's not talk about the problems, let's talk about the benefits. So once again, Hanji, so let's talk about this. So let's talk about or let's take the example of the joint family. So in the joint family, beta, so many members are there, right? Obviously, there is a love. Matlab, it's not like you're dependent on your mother only. You will be having grandmother, will be there, right? That those who are going to take care of you. Even if let's suppose there will be a trouble, right? Whenever there will be any trouble, all the family members, they'll be together. If one will be in a problem, others are going to protect them, है ना? And if let's suppose by any chance, right, if there is some severe issue, then what will happen? They'll support each other, so they'll be having the ability to bounce back. Resilience will be there. So it is like that, right? So stable community should not show too much variation in productivity. It will be either resistant or resilient too. Resilient means your ability to bounce back, right? Okay, problem is there, you are harmed, but you will bounce back again. So it must be either resistant or resilient to the occasional disturbances. Is that clear? So it must also be resistant to invasion by alien species. So here we have third scientist name, David Tillman's long-term, guys, something happened. Now am I visible? कैमरा, कुछ तो हुआ था कैमरा में, वीडियो क्लियर नहीं था। कैमरा में एकदम कुछ तो हुआ था, वीडियो क्लियर नहीं था, एकदम ब्लर हो गया। इस पे स्क्रीन पे देखो एक बार। Now fine, chalo. So have a look. Have a look. So what are we saying? So David Tillman's long-term ecosystem experiment. So third scientist, what he did, he used some outdoor plots, right? So Tillman found that the plots with more species showed less year-to-year variation in the total biomass, and I have already explained you the reason behind that, right? So I have already told you, just let's suppose a one type of crop is there, it will be destroyed if there will be so many. The fertility of the soil is also maintained, beta, and the biomass fluctuation in productivity will not be that much. Okay? Now, species richness, this is very important overall for the, like, even for the ecosystem health, for the human race, right? We should have, right? We have to maintain the species diversity, in simple words, beta, and we are losing species at an alarming pace. Okay, beta. So here they are saying ki Western Ghat ecosystem will be. Now the question is ki why? Why do we need the species diversity? What is the requirement? Right? They are saying ki what will happen? Just Western Ghats mein, right? The frog species is decreasing. How is our quality of life affected if this will be there? So now the fourth scientist name here is Stanford ecologist Paul Ehrlich. I told you. So he gave us an analogy, beta, that is ribbit-popper hypothesis, my favorite. So he gave us what? An analogy, which is the ribbit-popper hypothesis, beta. So with the help of that, he explained. Simple here. So airplane is what? You can consider an airplane as ecosystem, right? So rivets here, matlab nut bolts here. Rivets here are compared with the species, bache. And when you talk about the critical, the important rivets, right? The main rivets, you are talking about the keystone species. You are talking about the like species which are very important, right? Keystone species, main species. So let me explain that to you. So he said, right? Compare an aeroplane with the ecosystem. Now, initially, that is in good health. Now, let's suppose passengers are coming, right? We are popping the nuts there, rivets there. We are popping them out. So, initially, it is not going to harm. Just you were sitting, right? You are just popping out the rivets that are linked to that chair or something. Okay, it is not damaging that plane that much. But don't you think with time, don't you think with time it is going to damage it a lot? And let's suppose if someday somebody will remove the or pop out the rivets from the airplane wings, then what will happen? Damage. So no doubt species diversity is there. It is not harming us that much. But someday, because of all that thing, if by any chance, if some main species, key species, if it will get eliminated, then what are we going to do? So keystone species are the one which are having an important role in the environment, in the ecosystem rather, right? So this is what they are saying. They are saying that in an airplane, which is compared with what? In an airplane, which is compared with what? Which is compared with the ecosystem. All parts are joined together by using thousands of rivets. So rivets are compared with the species. So if every passenger traveling in it start popping a rivet to take home, right, means if it is causing a species to become extinct, it may not affect the flight safety. Proper functioning of the ecosystem will be there initially, but more and more rivets are removed, beta. Plane will be weak, and over a period of time it will be weak. Which rivet is removed may also be critical. Just let's suppose if there will be loss of rivets on the wings, that is key species that drive major ecosystem function, is then there will be a threat to the seeds. There will be a threat here. Got it? Got it? Any doubts? Any doubts? Sure? Sure? So keystone species या key species, what are we talking here? So keystone species matlab they are low in number, but they are, you can say that they are having very large ecological impact. Okay, their removal can cause major ecosystem changes. So you can also call it as keystone species. Now, loss of biodiversity loss mein beta, here you will have a trick that you have to remember. That is HOAC. That's the trick you have to remember. What's the trick that you have to remember? The trick is HOAC. So what is this HOAC? HOAC is the trick. Habitat loss and fragmentation. HOAC is the trick, that is habitat loss and fragmentation. Then over-exploitation is there. Over-exploitation is there. Alien species invasion is there. Alien species invasion is there. And then we will talk about co-extinction. This is HOAC, HOAC. So I mainly form tricks on the basis of initials so that I'll be able to remember them for a longer period of time. So now what are they saying here? So they are saying ki we are not sure that whether new species will be added or not, but species are continuously losing bache. So here they are giving us example, that only I'm highlighting, the colonization of tropical Pacific island, right, by humans. When humans started living there, it led to the extinction of more than 2,000 species of native birds. So imagine how dangerous are we. Then IUCN Red List documents the extinction of 784 species beta. So in that 784 species, you have 338 vertebrates, 359 invertebrates, 87 plants. Imagine the number here, and that too in last 50 years and 500 years. And let me remind you beta, let me remind you, this is not as per latest data. Latest data is worse than this. Okay, now here we have the examples from where they ask the question. So dodo, Mauritius, quagga, Africa, thylacine, Australia, and stellar sea cow, Russia. So they are, and the three subspecies. So these are the three subspecies of tiger, not of lion. It is Bali, Javan, and Caspian. It is Bali, Javan, and Caspian. So this is what you need to keep in your mind. So dodo, Mauritius, quagga, Africa, thylacine, Australia, stellar sea cow, Russia, and there are three subspecies, Bali, Javan, Caspian of tiger. So last 20 years alone have witnessed the disappearance of 27 species. So imagine. So yes, so this is the data you have to remember. Dodo Mauritius, Quagga Africa, right? Thylacine is going to be from Australia, Steller sea cow is from Russia. And 3 subspecies of tiger, Bali, Javan and Caspian. So it is not of lion, it is of tiger. Do not make this mistake. Keep it in your mind. Is that clear? Right? So even amphibians, they are beta extincting at a more vulnerable rate than the see, animal species, mammal species and amphibian species is same, but their threat to extinction is more. Why? Because we are trying to convert that ghats into the lands where we can make our homes, and it is not good, because one day even nature will also bounce back. Okay, so the amphibians, they have more threat than the mammals, right? So they are saying, so adding to the grim scenario of extinction, more than 15,500 species worldwide are facing the threat of extinction. So presently, so maximum threat beta, where will you see? 32% will be there in the on the amphibian species, maximum. Then gymnosperms beta 31%, mammals 23%, 12% will be on the birds. So that's how I remember. Maximum 32. Who? Amphibians. 31 gymnosperms. Then what will you have? Right, least is basically for the mammals, and then least is basically for the birds. 23% is basically for the mammals, and the 12% will be for the bird. So this data, what is the easy way to remember that? Just keep reading it. Don't try to memorize it, just keep reading it. Whenever you open the NCERT, that's why I'm highlighting it. I'll also share the PDF in my personal Telegram group, that is Love Biology by Ambika, or in the WhatsApp group as well, which is of PW NEET English. In both the groups, I will share the notes. Whatever I'm highlighting, just recall that, okay? So here they are saying, right, so this is what you need to remember, okay? Okay, so so it's not like that this extinction is the first episode. We have already seen 5 episodes of mass extinction of species. This is going to be the 6th one. But why is it dangerous? Because the current species extinction rates are estimated to be 100 to 1,000 times faster than in the pre-human times, right? And our activities are responsible. So we humans are responsible for that, and the rate at which the extinction is going on, it's quite fast. That's the point here. So loss of biodiversity, what will it do, beta? Decline in plant production, lowered resistance to the environmental disturbances, right? And increased variability in certain ecosystems such as plant productivity, water use and pest and disease cycle. So they are saying plant production will be less, number 1. Right, number 1, plant production will be less, beta, number 1. Number 2 is resistant to environmental disturbance will be less, and variability in certain ecosystem, jaise ki be it plant productivity, that will also vary a lot. Water use, pest and disease cycle, the changes will be there. So causes of biodiversity loss mein, I told you clearly what you have to remember. It is going to be HOAC. So which one is the major cause? This one is the major cause, that is habitat loss and over exploitation. Beta, obviously, if let's suppose if we are blessed to have homes, if we have to sleep, right, without home, just let's suppose you are sleeping here and there, right, somewhere near to the or footpath or something like that, so you will be under more threat, na? Anything can happen with you. Same is the case here. So if habitat will not be there, how that animals will feel protected? Some animals, they need large territories, right? If their habitat is not there, they'll be more vulnerable for the predation as well. So that is why habitat loss is and the over exploitation is and fragmentation is the major cause. So here, what is happening here? So these 4 things are referred to as evil quartet. That is again a PYQ. So it is HOAC that you have to remember, beta. So first of all, most important cause that is causing the animal and plants to extinct is the habitat loss. This is a PYQ, number 1. So here they are giving us an example. They are saying, just say Amazon rainforest, just a tropical, right, they are giving tropical rainforest. Overall tropical rainforest, they were covering more than 14% of Earth's land surface. Tropical rainforest, now it is just no more than 6%. Imagine, more than 14%, not more than 6%. Look at the difference here, right? And here, this is something that even I have studied when I was in class 12. By the time you finish reading this chapter, 1,000 more hectares of rainforest would have been lost. Now, another example is Amazon rainforest. Here, Amazon is also a tropical rainforest, but here in general, they are saying tropical rainforest, they used to be more than 14%, now 6%. It is Amazon rainforest, which are the lungs of the planet, beta. So here they are having millions of species, but they were cut. Why? For cultivating soya beans or for the conversion to the grassland for raising the beef cattle. So besides total loss, the degradation of many habitats by pollution is also there. So when large habitats are broken into smaller fragments, be it the human activity or anything, mammals and birds which need large territories and migratory habits are badly affected. So obviously their population decline. So over exploitation mein beta, we have the example of passenger pigeon, right? So here you can see Steller sea cow or passenger pigeon. They got extinct due to the over exploitation by humans, right? So nature is having everything for our need but not for our greed. Third example is beta alien species invasion. Matlab a species which is not the part of that particular area, we are introducing it there. Now you understand, because it doesn't have its natural predator there, so it will widespread, it will cause harm to another one. So these are the examples here, right? So just say one example is Nile perch. Nile perch, pay attention. It was introduced into Lake Victoria in East Africa. So Nile perch, so deliberately we have introduced that. So Nile perch, it was introduced where? Into Lake Victoria in East Africa, due to which the extinction of more than 200 species of cichlid fish, right, in the lake occurred. Nile perch, where was it introduced? It was introduced in Lake Victoria in the East Africa. Because of that, 200 species of cichlid, 200 species, it's not 200 fishes, it is 200 species. Imagine each species will having so many organisms. So 200 species of cichlid fishes in the lake, they also got extinct. Is that clear? Another example, just we have discussed carrot grass. Remember Parthenium, your lantana, and water hyacinth, which is Ecornia. They all are the example of this. And here you have this Ecornia is also known as terror of Bengal. So beta, it was introduced in India because of its beautifully shaped leaves and beautifully colored flowers, but it turned out to be invasive. It is having offset by which it propagates at a very fast rate, and due to which it takes out all the dissolved oxygen from the aquatic body, and the aquatic life, it will not get the sufficient oxygen and they die. So it is also terror of Bengal. And one more example here is African catfish, Clarius garipinus, right? It is for aquaculture, it was introduced, right? It caused a threat to the indigenous catfishes in our river. So examples are important. Baki co-extinction, you know that two species, they are dependent on each other, be it in host-parasite relationship or in the case of pollinators. So if one will get extinct, the another one will also, right? So when a species become extinct, the plant and animals associated with it in an obligatory way. So do you understand what's the meaning of obligatory way? So obligate, mane strict, mane they need that particular plant or animal only, they will not go for anything else. So they will also get extinct. So this is what they are trying to tell us. Baki beta, biodiversity conservation, you have in situ, ex situ, but what are the reasons here? So we have ethical reasons. First thing is ethical reasons, right? We are the organisms with self-consciousness, so why can't we protect other? Why can't we conserve other? So I believe ethical reasons are the most important one, but here they have given us some other reasons also that are narrowly utilitarian or widely utilitarian reasons. Is that clear? Is that clear? So narrowly utilitarian means the direct benefits that we are getting from the organisms, right? So wherever you are talking about, right, whenever you talk about this, narrowly utilitarian, so here you will see direct benefits that we are getting, right? Jaise ki food, firewood, fiber, construction, all of that we are getting from it. And more than 20% of the drugs currently sold in the market are derived from the plants. 25,000 species of plants, they contribute to these medicines used by the native people. Is that clear? Is that clear? So here there is a term which is very important, beta. So I posted a short video where I have explained it, bioprospecting, right? Bioprospecting, this is very, 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 very important. So in 2026 also they asked a question from this particular part. We have discussed it also. So what is this bioprospecting, bache? Bioprospecting, you are using living organisms to take benefit out of that. Jaise ye dekho, exploring molecular, genetic and species level diversity for production of economic importance. मतलब you are studying living beings, be it a plant, animal, microbes. You are exploring, you are checking their molecular things, you are checking what are you getting from them. So you are studying them. Why? Because you know or you want to make something which can give you economic benefits. So this is something very important. Now, after narrowly utilitarian, you have broadly utilitarian arguments also, right? So this means indirect benefits that we are getting. So imagine, see, obviously these fast dwindling Amazon forest, it is giving us, right, photosynthesis, it is doing 20% of the total oxygen in the earth atmosphere. So isn't it important? Obviously important. Otherwise, we have to carry the oxygen cylinders. What will we do then? Baki pollination is the another service, right? So ecosystem provide through pollinators, right? So we have bees, bumblebees, and birds. And if we have to pay for it, so imagine, right? So if we have to pay for it, what are we going to do? So next is the ethical argument. I told you this is the most important thing, right? We owe to them. They are giving us the benefit. It's our job to protect them. So that's what you need to understand here. Baki beta, how do we conserve biodiversity? So ex situ and in situ ways. Ex situ and in situ. So ex situ, in situ means what? In situ, on site, means you are protecting that living organism in their wild habitat. You are not moving it here and there. You are protecting it there only. Jaise in situ mein, on site mein, you have wildlife sanctuaries. And do check the difference in wildlife sanctuaries and national park. You have national parks, beta. You have wildlife sanctuaries. You have national parks, bache. You have biodiversity hotspots also. Yeah, biodiversity reserves also, I would say. And here I'm sticking to the NCERT, sacred groves and all are there. Matlab we also have extra pointers here, but here I'm just decoding NCERT for you. So here they are saying what? Here they are saying what? So in situ means you are protecting them in their natural habitat. And when I'm talking about ex situ, just say you have zoological parks, right? Then we have botanical gardens, right? We have wildlife safaris also. So cryopreservation, the most advanced ex situ conservation way, beta. So seed banks and all, this is what we have. Okay, so in situ, right? So what are they saying? So here you have, so in situ conservation, which is faced with conflict between development and conservation. So many nations find it unrealistic and economically not feasible to conserve all the biological wealth. So here they are saying that number of species waiting to be saved from extinction, it is more than the resources available. So what they have given, so here we talk about the biodiversity hotspots, beta. So what are the biodiversity hotspots? This is a very important data. Biodiversity hotspots, beta. Biodiversity hotspots are area, right? Biodiversity hotspot, this is something very, very, very important, I would say, right? Biodiversity hotspot. So who gave that concept? So it was given by, concept was given by Norman Ware, right? This Mayor, this is very important. So please pay attention. So what are you talking? You are talking about the biodiversity hotspots. What are you talking, beta? You are talking about the biodiversity hotspot. So who gave that concept? So concept was given by Norman Ware. So here you are talking about the areas which are showing, right? Matlab, what are the condition for something to be a biodiversity hotspot? It should be rich in biodiversity. It should show endemism. Endemism means it should have the species which are restricted to that area only. They are not here and there, they are present in that area and it is under the threat to extinction. So if we protect them, we can decrease the threat of extinction by 30% around. Okay? Okay, so hotspots, so what do you see there? So high endemism, high species richness and habitat loss. This is the gist of this. High endemism, high species diversity and threat of extinction. Threat of extinction. This is what you have here. So endemism means endemic species. Endemic species, they are localized to that particular area, not found anywhere else, right? Not found anywhere else. That is what you have to remember. Anywhere else. We will not find it anywhere else. Is that clear? So localized to a particular area, you're not going to find it in anywhere else. So this is the meaning of endemic. So endemic means restricted to a particular area. So if there is a biological, if there is an area where too many species are there, plus you have the endemic species which you will not found anywhere else, plus there is a threat to extinction, then beta, these are the biodiversity hotspots. Initially they were 25. Then beta, what happened was 9 more were added. They become 34. So 34 is as per the NCERT data, but latest is basically 36. So out of these 36, just here as per NCERT, out of 34, 3 are in India. Just if you will read the NCERT, this is what they say. So as I told you that you should know the latest data as well. So now it is 36 and 4 are in India. Yes, this is something that you should know. So you have to remember both. Now if you will ask me, ma'am, in paper, if 34 and 36 both are given, go for 36 because it is the actual concept. Okay, so 4 are in India. Okay, so these are the biodiversity hotspots. So Norman Mayer concept it is. So initially 25, right, and then 9 more were added. So total number is 34. So now I told you, as per the latest data, the number is 36 now, and 4 are in India. And it is not something we should be proud of. It means one more area is under the threat to extinction, which is not good. So yes, so it is happening because of the habitat loss. So in India, we have Western Ghats and Sri Lanka, Indo-Burma and Himalaya. They cover our countries, high biodiversity. So all the biodiversity covers less than 2% of Earth's land area. Imagine we are not able to protect less than 2% of Earth's land area. So number of species they are having is extremely high, and strict protection of these hotspots can reduce the mass extinction by 30%. Imagine. By 30%. So in India, bache, so they are saying ecologically unique and biodiversity rich regions, जैसे biodiversity, this biosphere reserves are there. So do you know about biosphere reserves? Do you know about biosphere reserves? So beta, it is basically a concept. It was established under MAN, right? That is Man and Biosphere Program of UNESCO. It was established under MAB program of UNESCO. UNESCO. So that's your homework. In the comment section, I want the full form of UNESCO. So what is MAB here? Man and Biosphere Reserve. Man and Biosphere, right? What is this MAB? So MAB is basically Man and Biosphere Program of UNESCO. Is that clear? So it is having beta 3 zones: core, buffer and manipulation zone. So let me tell you this so that you don't make mistake here. Let's suppose if I'm making it like this. So let's suppose there will be core zone, there will be buffer zone, and there will be manipulation zone. Right? How many zones do we have here, beta? How many zones do we have here, bache? So we have 3 zones, right? The first one is going to be the core zone, right? Buffer zone, or the manipulation zone, which is also the transition zone. So in this zone, right, it is no human activity. No human activity, matlab nothing. It's highly protected. No human activity is there in this particular region. Right? No human activity. It is that much protected. Okay, it is not concentric, but it should be. Matlab, I made this diagram not properly, but you remember that. Strictly protected, no human activity. So here you will be having limited human activity, beta. But that human activity, it's too limited. It should not harm the wildlife present there. Not at all. Not at all. And then comes beta transition zone, manipulation zone. So sustainable human activities, right? So here what will be there? Sustainable human activities are there. Okay. So when it comes to sustainable human activities, जैसे कि tourism, for research purpose, right? Forestry, like this. Okay, okay, right? Forestry, agriculture, tourism, like this. So this is allowed, nothing else, nothing else. So national parks are also there, sanctuaries are there. So India has 14 biosphere reserves, 90 national park, 448 wildlife sanctuaries. Obviously, this data is not latest. Okay, only NCERT data I'm showing you here, and this data is also not the latest one. Is that clear? So the number, right? So the number, so you can even see that if you want to check the latest data. So biosphere reserves are not 14, they are 18. National parks are, I think, around 106, right? So you can just check it. It is around 104 rather than 90. So you can, here you can just check that, but this is as per NCERT. So other than that, beta, here you will talk about the sacred groves. So what are sacred groves? The places that we worship, right? It can be any forest, anything. So jaise there are many forests, right, which people worship, and they don't allow to cut even a single branch from that, and because of that there are many endemic species in there, that areas as well. So it can be sacred lakes, right, sacred forest, it can be anything, beta, right? So even in South India, right, if you guys have seen the movie Kantara, in that Kantara movie is all about this. There is an area that will be protected by the people living there, right? They are not destroying it, they are not letting anybody destroy. So that is what you can understand. Okay, so basically India has also a history of religious and cultural traditions, right, that emphasize the protection of nature. So in many cultures, tracts of forest were set aside, all the trees, wildlife is protected there, right? So we have the example, beta. So they are found in Khasi, Jenshia Hills in Meghalaya, Aravali Hills of Rajasthan, Western Ghat regions of Karnataka, and Maharashtra and Sarguja, Chanda and Bastar areas of MP, that is Madhya Pradesh. So that is what you need to remember. And in Meghalaya, they are saying the sacred groves are the last refuges of large number of rare and threatened plants. Is that clear? Is that clear? Baki beta, in XC2 conservation, they are simply saying you are having what? Zoological park, botanical garden, wildlife safaris, right, beta? So they are those who are extinct in wild. We take them to the special habitat, we provide them special care, they'll be allowed to mate there as well. So that's how we try to protect them. Okay, beta? Okay, beta. So there are many animals that are extinct in wild. You will not find them in their wild habitats, right? But they are still in the zoological parks, right? Right, beta? So an advanced way of this is basically cryopreservation. Cryopreservation. So by that, though, we can even protect their eggs. Even if it is a plant, we can protect their pollen grains, yeah, seeds, etc., etc. So in cryopreservation, what is happening? So you can remember, it is an advanced XC2 conservation method. It is an advanced XC2 conservation method. This is the first thing that you all can remember, that it is an advanced XC2 conservation method, number one. Number two is here in minus 196 degrees Celsius, right? At minus 190 degrees Celsius in liquid nitrogen, you are going to conserve that. These both the things are important. Okay, beta? So we can just conserve their gametes, their eggs, right? And later by tissue culture, we can promote them. So this is what, so seed banks, gene banks, they all are there. Okay, so baki beta, this is the last part. Then we'll solve the MCQs. So biodiversity, it knows no political boundaries. Its conservation is therefore a collective responsibility of the nation. So question can come from this part too. Just say we have historic convention on biological diversity, the Earth Summit. So where was it? Rio de Janeiro in 1992. Okay, so what they decided, that they'll take appropriate measure for conservation of biodiversity and sustainable utilization of the benefit. After that, beta, the World Summit on Sustainable Development. So it was in Johannesburg, South Africa. 190 countries, they pledged to achieve this thing by 2010. So there should be the significant reduction in the current rate of biodiversity loss. So this is what we have here, right? So that is it. So do check the summary part. Now see, let's solve the MCQs, and the PDF will be shared, and then we will meet at 9 p.m. for what? For PYQ practice. For PYQ practice, right? So it is for the genetics as well as for the biotechnology. Done? Chaliye. So exploring molecular, genetic and species level diversity. Just now I told you this is the bio prospecting. So it's a 26 PYQ, which is in situ conservation. In situ beta 110 sacred groves. Then since the origin and diversification of life on earth, there have been 5 episodes. Why this 6th one? Because here beta the extinction rates are 10 to 1000 times faster than the pre-human times. Now look at it. From each and every line of NCERT, they are asking the question. So which one of the following is an example of ex situ conservation? So it is ex situ conservation, so zoos and botanical gardens. And then beta here, right, when it comes to the ribbit popper hypothesis given by Paul Ehrlich, right, so he compared the ribbits in an airplane to ribbits with the species, right? So that is it. This is all about today's class. So do revise it. I'll share the notes in our WhatsApp group. Now beta, next session is at 9 p.m. today, where we will practice the PYQ. Which next one shot you want? This is what you have to tell in the comment section, and the full form of UNESCO. Okay? So tada, bye bye, take care. Thank you so much everyone. Thank you.